Hello.
About the department.
Hello. A pleasant morning to all the invited guests, delegates, scholars, ladies and gentlemen. With great A pleasant morning to all the invited guests, delegates, scholars, ladies and gentlemen. With great joy and immense exultation, I am Divya, research scholar from Department of Agronomy. On behalf of Department of Agronomy, Faculty of Agriculture, Annamala University, we are delighted to offer a gracious welcome to all for today's international virtual conference on redefining sustainable food production in the context of climate change. Let us start this program with blessings of Almighty. We welcome all the dignitaries on and off the dais, guests, scholars to invoke the Almighty. Thank you, everyone. I'm profusely elated to welcome Dr. M. Mayappan Sir, Associate Professor, Conference Organizing Secretary, Faculty of Agriculture, Annamala University, to deliver the welcome address.
Good morning, everybody. It is a moment of pleasure for me to stand before you as a host to welcome all the dignitaries on and off the dais, the keynote speakers, the participants, my own colleagues, and the scholars of the Department of Agronomy. First and foremost, I welcome our Dean, who is also my teacher, and who is going to deliver the inaugural address. Sir, welcome you, sir. So I'm very happy to welcome my senior, my good friend, and our own HOD, Dr. Imayavarman, sir. And thank you, sir, for your presence and help. So I welcome our former HOD, Dr. SN, sir, for gracing this occasion. And I welcome all my colleagues, that associate professor, assistant professors, research scholars, and PG students for this international webinar on redefining sustainable food production in the context of climate change. So I welcome the keynote speakers, Dr. E. Somasundaram and Dr. P. Ravishankar. They are all our own products. So they spontaneously accepted our invitation. That shows their kindness and respect towards Annamalai University. And they are going to glorify this event, a memorable one. So I officially welcome all the participants who registered for this webinar. And I'm happy that some of my classmates who studied BSc Agri 30 years ago also registered. So I salute and welcome them on behalf of the organizing team. So I wish everyone to imbibe more information through this webinar. Thank you.
It is a great honor for us to welcome our esteemed Dean, who is having renowned experience in both research and teaching, Dr. K.R. Sundarvardarajan, sir, Department of Agricultural Economics, Faculty of Agriculture, Annamalai University, to inaugurate the International Virtual Conference on Redefining Sustainable Food Production in the Context of Climate Change. We welcome you, sir.
Good morning. At the outset, I'm extremely happy to stand in front of you within a span of 5 days, again back for the Department of Agriculture. As I took a charge some 5 days back as a Dean of the Faculty of Agriculture, and the first and the maiden program that occurred on last Friday on agronomy, and again this Tuesday, again I am there standing in front of you to deliver the inaugural one. So I thank the head of the department, Dr. Imayavarman, for arranging such a wonderful program today and morning. We both of them were in the form from 7 to up to 8:50. Then within a short span of 30 minutes, again we are back. So that shows the meticulous planning and the hard work by his team. So I welcome Dr. Mayappan, the organizing secretary of this international virtual conference, and Dr. B. Sudhakar Rao, the organizing secretary, and the various technical session people, Srinivasa Perumal, Dr. Ravishankar, and Dr. R. Krishnamurthy, Sendil Kumar, Soma Sundaram, and all the Sivakumar and Rex Simonovel, all the organizers and senior professors, Natarajan, and all the professors of the Department of Agronomy, TM, assistant professor, associate professor, and from the other department, Rangaraj and all. So at the outset, I'm extremely happy to stand in front of you. So let me come to the point for the inauguration of this neat hour of the topic, redefining sustainable food production in the context of climate change. As everyone is speaking, India, with a population of 1.27 billion, with a land area of 323 million hectares, of which 154 million hectares of cultivable land, which is a gift when compared to China or erstwhile country. Having such a diverse and 15 agroclimatic zone, which is present in India, our food production has achieved, when compared to the last year of 297.5 million tons to the 2021 of 308.15 million tons in the year 2021. Though we say on climate resilience, climate change and everything, it is all because of the hard work scientists like us and the cooperation rendered by the farmers to bring such a marvelous food production in our country. So this year, we crossed more than 300 million tons of food production. This is a great achievement. We anticipate large fall in all the sectors of economy. The only one sector of sunrise economy is our agriculture. So far, agriculture has not been considered as any point of development one. But now people started considering it as a business, because this is the only one arena during the COVID which took of more than 300 million tons of production. So this 300 million tons rice alone form more than 107.8 million tons. And this year, for the first time, wheat also entered into more than 100 million tons. It crossed 1.5 million tons this year wheat production. So followed by all the core cereal. When you look at the economics of the core cereals, the increase is simply jumped from 42 million tons to 45 million tons this year. Similarly, the pulse production also increased to 25 million tons. So what all this shows that on one side, we are now doing very beautiful one. The India, you may be knowing that before October, it is the 6th largest economy in the world. Now it crossed, it has now retained to the next grade. It is the 5th biggest economy in the world in terms of GDP. Isn't it? We crossed the Great Britain. In the month of October, we crossed Great Britain in terms of the next to the US and China and all the very big German economy. India has now entered into the 5th largest power in the world. But on compared to the price parity, the purchasing price parity, what we call, that determines all the thing value, India is the 3rd purchasing power parity economy in the world. This is on one side. On the other side, we say the climate. So there is a vast change in the climate in the last 10 years. The Paris conference, which held in the year 2014 itself, says that it has to be agreed by all. The then president of the US, he didn't participate. He left. There are a lot of even cry on that one, but still we made. And nowadays, you might have seen this newspaper. And officially, yesterday only, the Indian Meteorological Station declared that the northeast monsoon has started. So it has to be 1 month back, but there was a delay. But on contrary, we say southwest monsoon has gained more than 64% of normal rainfall to Tamil Nadu. It ranges from 90 to 47%. In few districts, more than 90% excess of rain. And this rain is a torrential rain, a downpour. They say different names they give. It's a burst of clouds. And within a short span of 1 hour or 2 hours, almost all the parts of Tamil Nadu received 10 minimum. It happens to be see that if you go through the meteorological report, it crossed more than in all the places 135, 145 millimeter, 165 every day it quotes. So we don't know the reason, maybe the climate change. The organizers maybe are looking at what is the impact of the climate change. On one side is extreme erratic rainfall. On both the drought also erratic, and weather also, chillness also erratic. Those places where supposed to be chill in the western part of the world, there is no cold at all. Certain parts where they didn't experience any of the rainfall, there is excess of rainfall. And the new places, it has happened some 3 months back, torrential rain in the German, which is they never, everything they say, history on more than 50 years, 80 years, 7 decades, 10 decades. So this is a very good topic, food security. And you may be knowing that in India, 123 million people are still undernourished by the World Development Report. It says that there is a difference of opinion between economies of the various group. One says it is 20% under BPL or under poverty. Another study, NSSO, says that it is 30.82. World Development Report says that it is 38. So there is a difference of opinion between the various government agencies in calculating the poverty. But anyhow, we accept that minimum 25% of our total population of 1.27 billion are undernourished or poverty. In this context, this food security, and India ranks in the 73rd among the 113 countries in the food security index. So that shows that there is a need for agronomists to work a lot. that clearly indicate that we are not in the bridge. So out of 113 countries of the Food Security Index, India ranks in the terms of 73. So we have to go through. So there is a large demand. There is a large work the country expects from agronomists to nourish this country, the people below the poverty, and the ultimate aim should come, the poverty level should come within less than 2 digits. So it is in the hands of the agronomists to redefine what is sustainability in the context of food production by taking into the climate change as one of the main factors. So I welcome our former dean, Dr. Ganapathy, for this function. And thanks for giving this type of opportunity for us to share my own thought on the climate change and food production. So with the diverse of agroclimatic zone, with the erratic changes in the climate, it is a time. So I appreciate the organizer for choosing such a wonderful topic and also inviting global leaders from throughout the world for the virtual conference. My sincere request for the students and the other teachers to kindly listen. It is a very good opportunity given to us, the corona. The positive, when you take the SWOT analysis of corona, it emerged this type of virtual conference. Earlier, it is highly impossible to meet all these people. Now, everyone is coming in our screen. So it is a bound duty of my sincere request to the students, kindly utilize this, ask more questions and develop your knowledge. For that only, all the peoples are working for you to get exposure. So it is a time for us to get this exposure and come up better in their life. So I thank the authorities for giving this type of opportunity. Once again, I am happy to stand in front of you for the second time. Thank you very much. Thanks a lot.
Thank you for being with us every time, sir. And you have shared a good knowledge about agronomists and their importance in this agriculture, sir. Now, with great pleasure, we cordially invite Dr. V. Imayavarman, sir, Professor and Head, Department of Agronomy, Faculty of Agriculture, Annamalai University, to present the felicitation address.
Good morning to everybody. I'm happy to stand before you to felicitate today's organizer and today's virtual conference. And the topic is well suited and it is in need of this hour because already our beloved dean narrated all the important points regarding the climate change and its impact and how the sustainability will definitely redefine the livelihood of the farmers because the changing in the climate, which makes difficult in doing agriculture operation or cultivation when less difficult. So this organizer is selecting a good title, that is redefining sustainable food production in the context of climate change. Now we felt the impact of climate change on all the sectors, starting from the health, food, and all other sectors. So here I am very much thankful to the organizing secretary, Dr. Mayappan, for choosing this title, and also see that the eminent speaker from Mr. Dr. P. Ravishankar from ESA, who is also alumni, and another man, Dr. E. Somasundaram, professor from TNIU Coimbatore, who is going to deliver some interesting and useful title and speech on the sustainable production. And I request all the participants kindly connect with this seminar on virtually and get benefited and transfer these technologies to the people, those who are in need in this hour. Thank you for everybody for giving this opportunity. Thank you.
Thank you for your support, sir, and for your felicitation address. We extend our heartfelt welcome to Dr. G.B. Sudhakar Rao, sir, Associate Professor, Assistant Professor, Organizing Secretary, Department of Agronomy, Faculty of Agriculture, Annamalai University, to brief about the conference.
Most respected Dean, Faculty of Agriculture, respected Professor and Head, Department of Agronomy, prominent Professor, Associate Professor, Assistant Professor, and Honorable Eminent Speakers. Good morning to each and every one of you. I feel very glad and I am really grateful to have this excellent opportunity to speak about the International Western Conference on redefining sustainable food production in this context of climate change. A sustainable food production is a method of production using process and a system that are non-polluting, conserve non-renewable energy and a natural resource that are economically efficient, are safe for workers, communities, consumers, and do not compromise the need of future generation. But in future, climate change will make great impact on sustainable food production. We may think, is climate change a big sustainability issue? And yes, of course. One of the greatest challenges we face in 21st century is to sustainably feed 9 to 10 billion people by 2030, while at the same time reducing environmental impact, which pushes us to step forward into climate resilient agriculture. The farmer has to be an optimist or he wouldn't still be a farmer. But nowadays, the scenario has changed because of climate change that result in greenhouse gas emissions, extreme drought, heavy flood, forest fire, etc. This could disturb stability in the supply of food and the people livelihoods, making it more difficult for them to earn the stable income to purchase food. And this can be solved by following climate resilient agriculture, which also a part of sustainable food production. Climate resilient agriculture is an approach that includes sustainably using existing natural resources through livestock and crop production system to achieve long-term higher productivity and farm income under climate variabilities. Our lead speaker, Dr. B. Ravishankar, will discuss in detail about the role of genetically modified crops and crops are for sustainable agriculture. And Dr. E. Somasundram will give detailed discussion on organic farming for sustainable food production. Don't forget that agriculture is our culture. Thank you, Lars.
Thank you, sir, for presenting the overview of the conference. Let us move on to the important technical sessions of today's conference. For this, now I take this opportunity to welcome Dr. A.P. Srinivas Perumal, sir, Department of Agronomy, Faculty of Agriculture, Annamalai University, to introduce the speaker, Dr. P. Ravishankar, sir, Associate Professor, School of Plant Sciences, University of Arizona, USA, to deliver the lecture on role of GM crops and clustered regularly interspaced or palindromic repeats for sustainable food production.
P. Ravishankar is the alumni of Annamalai University. Dr. P. Ravishankar is the background light for the research. He obtained the BSc Agri from Annamalai University and the MSc from Plant Breeding and Genetics from Tamil Nadu Agriculture University, Madurai campus. He was honored with the PhD Genetics from University of Georgia, USA, and he completed his postdoctorate from University of Chicago, USA. He worked as a research professional at Chicago in 2006. He moved to University of Arizona as an assistant professor, and from 2016, he is working there as associate professor in the School of Plant Sciences. He served as a research mentor for many undergraduate students and was the chairperson for several science fair many years across the state. He reviewed more than 25 peer-reviewed journals and published many research journals like Cell, Plant Physiology, etc. He established the Polynomial Lab at the University of Arizona. In the training, many scholars on pollen grains, pollen tube, and fertilization research in the modern plant arbudosis and now in tomato. Thank you, one and all.
Hello, everyone. Can you hear me? Hello. I want to make sure everybody can hear me.
Yes, sir. Yes, sir.
Okay, thank you. So can I go ahead and start?
Yes, sir.
Okay. Okay. I hope you can see my screen. Vanakkam. Ellorkum vanakkam. Thank you so much for the kind introduction. And I also want to thank the organizing committee for inviting me to give this lecture. It gives me great pleasure to talk to my alma mater, where I started my journey as a working with plants. And it gives me great pleasure to join you all. It gives me great memories seeing that podium. It's brings back great memories for me, and I cannot express my appreciation and gratitude for having this opportunity to talk to you all. So today I'm going to talk about. My name is Ravi Palanivelu. I'm a professor in the School of Plant Sciences, and I've been working with genetically modified organisms in the model plant Arabidopsis, and now we are working with tomatoes. And therefore, I felt that this topic would be very ideal to talk in the context of sustainable agriculture, the role of GMO crops and CRISPR. So before we get into it, I wanted to define sustainable agriculture. The way to see it is that it is the best of all the worlds, right? In fact, sustainable agriculture was defined by the 1990 Farm Bill in the US Congress in this manner, where it is the perfect intersection of people, planet, and profit, right? So that way, agriculture continues to be a business, continues to be a way of life, continues to be a profession, but at the same time, it should happen in a way that is not destructive to the environment and also not harmful to people, and serve the original mission of feeding the world. Right. So, but this type of, because of this perfect symmetry that was expected for sustainable agriculture, it has to be not only for a few years, but for years to come, so that we have a world where we can thrive and grow food and feed the population without destroying the planet. But at the same time, not be in a sustenance farming, but sustainable farming, so that it is also allowed profit is made and it's used as a business and a profession. So if you keep that in mind, it's really important to think about sustainable agriculture today in the real context, because there is several factors are colluding and is posed a big challenge. The key is climate change, which is a major factor that is affecting all our lives all over the world, and no place is exception, no culture is exception. And this is combined with the challenge of climate change. We also have loss of arable land. So we do not have unlimited amounts of land where we can just keep growing. So it's important that we understand that part. On the other third challenge is that there's growing population. We expect to have about 9 billion people by the year 2050. And during all of this, there's another thing that is we cannot forget, is that there is environmental degradation due to extensive farming and rapid growth in many parts of the world. We have now managed to damage the environment beyond allowed limits, right? And finally, if we continue to have this population and if we continue to grow and if we continue to have to feed them, then there is also the need to have the agriculture be happening, but the cost of doing agriculture has gone up too. So because of all of these reasons, the sustainable agriculture, is it possible? In fact, I would argue that it is the perfect solution for all of these challenges, right? So, for example, let's talk about climate change. This is, I'm showing, obviously, I'm living in the Tucson area, which is in the southwestern part of the United States. It's part of a desert. It's a very arid place, and it's already a very warm place. But even there, you can see that since it is expected that the winter temperature would be rising and the summer temperature would also be rising. I hope you can see my cursor. Same way, the number of days that Tucson will experience 95 degrees or above will also increase from 102 days to 179 days in 2080, right? So, and if you look at the, just in June, this is a weather pattern in Tucson area. So you can see this is where I'm right now talking to you all in the southern western part of United States. We are just 50 miles from Mexico border. And this is already an arid place. In June, you can see the swing in temperature, very high, rapid change in temperature. And if you look at the average in the United States, if you look at the temperature in different months, like we picked 4 months in the year, and if you look across from 1981 to 2010, what the average is, but what is expected in the coming years, it is actually quite scary, right? You can almost see that at any time of the year, the average temperature is going to go up. And this is not sustainable, right? If this happens, we have to fundamentally change agriculture to match that demand that is coming. Just to give more reasons to think that if anybody has any doubt about climate change, that it is whether it's happening or not, I hope I can convince you that it is here. And we have to deal with it. Tucson, for example, broke the 125-year-old record when it crossed 150 degrees Fahrenheit. You can see the blaring headlines just this summer, right? A few months ago. Climate change won't be, Arizona is already making the heat wave that is normally there worse, and it won't be the last one. It is reaching 100 degrees by 8 a.m. Normally, those kind of temperatures, 100 degrees Fahrenheit comes around noon or 2 o'clock. It's only at 8 a.m. So daily temperature, seasonal temperatures, average temperature, everything is going up. And therefore, it is going to be a challenge. What about arable land? Let's not forget that we need land to cultivate and grow crops. It's going down, right? And that is also worsened by the climate change. So in addition to harvest losses, we now have 20% less arable land to grow our crops, right? What about population? On the other side, population is increasing, right? So like I mentioned, we are expected to hit 9.5 billion people by 2050 and keep growing. And so we have to feed the growing population. And we have crossed enormous environmental degradation over the years due to industrial revolution and also intensive agriculture. And the cost of doing agriculture is rising. I'm just showing some evidence that these are all big challenges. But in face of this challenge, can we just run away or we stand and face it? And I feel that sustainable agriculture is the solution by which we can actually combat all of these challenges and have food for the people that are living in the world. But if you think about sustainable agriculture, there are many aspects to it, right? Starting from economics, policy, regulation, agronomy, pest management, weed management, every aspect of it is there. Germplasm to supply good crops and everything. But I feel, and that's why today I'm going to talk about this, is that one of the things that is being overlooked is the GMOs and gene-edited crops, right? So I feel that is an important solution that should be on the table for us to take advantage and use it as a tool and keep it as a tool in our toolkit so that we can actually be able to combat these challenges. And we are ignoring this solution, which is, in my opinion, is one of the key solutions, and we are doing it at our own risk. I'm not familiar with all the policies and the current situation in India. So it's even more important that I hope I would make people in the audience, especially those who are from India, who are going to influence policy, research, decision-making in the coming years, to consider what I have to say today. So when I come with a message, it's a very scary thing, right? When people say GMOs or gene-edited crops, suddenly red light goes up, right? And it is very unfortunate. And there are several reasons why that is happening. But today, I want to assure you that that message I'm going to give you today is solely on GMO crops and gene-edited crops. I'm suggesting that it be part of our sustainable agriculture and also organic agriculture, which my former classmate and friend, current friend and former classmate, Somasundaram, will be talking. I want him and people who are thinking about it, and also the audience, to consider GMO crops and edited crops to be also part of all types of agriculture going forward. But when like I said, I can assure you that I'm not sponsored by any company or agency. I have no conflict of interest. So you don't have to fear that I'm actually advocating because of something, because I got money or something. I have a personal interest, vested interest in doing this. No, that's not the case. I'm speaking solely as a global citizen who's concerned about the planet I live in, and I want my children and future children of this planet to enjoy and thrive in this planet. With that kind of very noble thoughts, I'm coming to you today. And therefore, you don't need to fear the message. Therefore, you can trust the messenger today and give me your time and thought process, because I'm interested in genuine solutions to real problems, right? So, and I also want to provoke your thoughts, right? I want to talk about controversial subjects so that I make you think. Because if we are not if you are uncomfortable, if you are struggling, if you are worried, if you are passionate, if you are emotional, if you are angry, it is a good thing, because that means you're thinking. If everything is okay, we'll be complacent. And I don't want you to be complacent today. I want to provoke your thoughts so that we can go forward. So that's the context in which I'm going to give my speech today. So one of the overlooked, I still consider GMOs and gene-edited crops are overlooked in this thing. So global agriculture must increase output, right? There's no escape for it, because we have a global feeding population, people are coming. And only by improved seed varieties can we do. I mean, most important part of agriculture is the crop. And if that crop is coming up with an ideal solution to be able to combat all the things that we talked about, then we have a chance to continue to maintain our yield and succeed in what we need to do. And I feel that GMOs and gene editing is key aspect in giving that solution to improved crop variety that are designed. You can call them designer crops, but they are going to combat all these problems, right? So it's really important that the one easy way that we can actually achieve that is through GMOs and gene-edited crops. But I think that the long-term prospects are good, but we are totally dependent on policymakers, because there could be problems along the way that we could, especially I'm talking from the experience with GMOs, that what has happened. I am very concerned that it may also have the gene-edited crops, that we are going to throw the baby with the bathwater, right? Trying to worried about one thing, we are going to throw away the solution that is handily waiting for us to use, right? So I'm trying to convince you against that thought process, and request you all to give GMOs and gene-edited crops a chance to see where the facts are and help it. Okay, so let's talk about it. So classical plant breeding helped us solve 1970s green revolution in the 70s, right? Norman Borlaug with wheat, and also with all the Iri varieties that were released in India and other Asian countries, like IR20. When I was a kid, I remember the ad in the radio, they were talking about IR20, IR36. So I used to wonder, what is that? You know, my father was a farmer, and he grew those crops, and he explained to me that, you know, these are amazing high-yielding varieties, short duration, short stature. You can quickly cultivate more than one crop. It's just amazing, right? And that solved an important famine and was the basis for green revolution in the 70s. But those were classic breeding, right? Where we generated mutants. IR20 is a mutant plant. IR36 is a mutant plant, right? People generated using gamma radiation in Erie, and then they used classical breeding to cultivate and, you know, homogenize the population and release the variety. But there are other methods I've listed here are all used in classical plant breeding, which are very important, which should continue to grow. This is one thing I always see people when you're talking about GMOs or something. It's like, you know, like it's the classic thing is I can relate to you guys that if you are talking about, you know, if I say something very nice about Rajnikant, immediately the person will think that I'm against Kamal Haasan, for example, right? Or in today's terms, you could even call it between, when you say something nice about Ajit, people think something bad has been said about Vijay, right? Why is that? You know, both can coexist. Same thing. Classical plant breeding have an important place. They have developed concepts for us to use and continue to use. But the thing is that, but there are some things that we need to understand that plant breeding is a slow process. I'm saying that not in a bad way, but I'm just defining what it is true, right? It takes about 10 to 15 years, for example, a variety would be approved. That is because we have to cross the two varieties, select the progeny based on phenotyping, then we have to back cross, remove the extraneous mutations, undesirable traits, find what we need. So totally based on chance and having no idea where things are, what is happening in the whole plant. We just use phenotype to go after this process, right? So classical plant breeding takes time, but there's a place, no doubt about it. We should continue to do it. But let's think about beyond that horizon, right? So now I'm going to go into GMOs and gene editing crops. So there are some things I want to establish before I go into it to make sure everybody is on the same plane. Is that these things you have to know that it is dependent on this, what I'm showing in this slide, the central dogma of molecular biology, right? All traits in all organisms on this planet are designed or have their manifestation because of the code that exists in the DNA. And in the DNA is the at least most of the organisms. There's always RNA based organisms, but they're fewer in number for all practical purposes, especially for plants, it is in DNA, right? And they transcribe and make the RNA, which is the messenger, which is taking that code and will serve as the code in the ribosomes to make the protein, right? And then the protein will have function that will go on to define the phenotype or a trait, you name it, yield, height, color, quality, any aspect, disease resistance, insect resistance, all of these aspects are defined by central dogma of the molecular biology. Another important basic concept that we all must know in order for me to appreciate my talk today is that because both our DNA and RNA are nucleic acids, they are based on base pairings rules, and they follow similar base pairing rules, except for uracil in RNA, which is thymine in DNA. They have the similar nucleotides, and they are basically the building blocks of nucleotides, and they can hybridize. This is very important in order to understand CRISPR, we need to know this. So the DNA RNA hybrid can be formed too, that they can also base pair and form complementary. So what do we know about GMOs, right? So the idea of GMO is kind of cartoonish way I've depicted on the right side. So if you have a protein, and if you really want that to be present in the plant, and that's the precise thing you want to do it, what people have done is take that protein and look for the DNA that will code for that protein, right? and then insert that into a vector, we call it plasmid. And this gene could be from the plant itself. Let's say we are working with rice. It could be from the rice or from another organism, another plant, or from another organism altogether, right? It could be a green fluorescent protein from a fish or a jellyfish, for example. Anything. What we want to do, we could put it in a vector and then put this plasmid, introduce it into the cells, and hope that it will recombine into the plant genome and express that. That means the DNA will code for the RNA and the protein will be made. And then that protein, so now you have the enzyme being made in the cell. And now let's say this cell is making the protein that will be toxic to the, for a insect pest in corn. And then this corn is expressing that. So when the insect comes in and eats it, it will take the toxin and die. So the plant will take care of it. Right? So you have now an insect-resistant crop. Well, you can name your trait and you can do this. So whatever it is, the first step is insert new useful DNA into leaf tissue, for example, or even to other tissues. And once you introduce that DNA, you transform. That's the key part in this, is that you have to transform. That means introduce the foreign DNA and let it integrate into the genome of the host plant. And then you have to generate a plant from it, right? So what people do is use tissue culture, for example, to generate callus tissue first from those transformed cells that have, for example, like from this cell that has taken up the foreign DNA, and now you can regenerate a plant. Now this plant is now called transformed plant. It's transgenic. That means DNA has been moved from outside into it, and now that is now part of the genome of the plant, and now it can express it, make the protein, and do it, right? There is another way people have successfully transformed plants, is that called germline transformation. That means you take this DNA that you're trying to put it in, you can put it into the flowers where the eggs and the sperm cells live, in the pollen and the egg cells in the female. And if they get transformed, done. Now, when they fertilize and make a seed, you have the germline transformed, you can now set up a seed, right? Now you can simply plant the seed and you can raise a plant. Now that's a transformant because it is a transgenic plant. So in a variety of ways, people have introduced desirable traits, either, like I said, a gene that is from the same plant, you modify it in a way, or from another plant, or from a disease-resistant plant, or from another organism. And then you now the transgenic plant, which are GMOs, right? So the GMOs are shown, they're successfully grown and still cultivated in the United States are these crops like cotton. Most of the cotton grown in the United States today are GM cotton, and that is for the insect resistant. That has cut down pesticide use like tremendously, right? Sugar beet, soybean, which is a major transgenic GMO crop in the United States, corn, has improved the yield, and many traits have been improved. Canola, very important one because oil quality has been changed. Papaya, literally GMO saved papaya crop. In Hawaii, before the advent of this GMO, Hawaii is a major producer of papaya. There came a virus that was a very devastating virus, and nearly farmers lost all of the crop. It was almost endangered, but the people figured out a way to generate a GMO papaya. Today, nearly all the papaya grown in Hawaii are GMOs, and alfalfa and summer squash, for example. Right. So, but besides all this, there has been a tremendous backlash against GMOs. So what I want to take this opportunity to, some of the myths that have been floating around, are still floating around against GMOs, so that we can talk about it in a very, we are scientists, we can discuss data and we believe the evidence rather than fear and hearsay, right? Rumors and fear mongering. It has been now, I have listed on the left side, very reputable, including National Academy of Sciences. This is not a trivial organization. This is the pinnacle Hall of Fame for scientists, you can call it. And including that, many organizations have evaluated GMO crops extensively and have declared very clearly that they are safe by any measure. There have been zero acids, deaths, you name it. So I just, in fact, go through it quickly. One of the myths people say is that these genetically modified organisms cause health problems, including cancer. That's not true. There has been no link to GMOs as far as we know, according to, after reviewing 900 GMO studies in 2016. Right. GMO crops are too new, so we don't know if they are safe, right? It's like brand new. I'm worried. Let's wait and see, right? And that is also not true. GMO crops have been around for a while, and they have always shown to be safe. Third myth that is usually floating around is that GMOs are bad for the planet. This is actually cannot be true. In fact, this is why I'm advocating GMOs for sustainable agriculture, is because this has really reduced many aspects of our agriculture. Like, for example, farmers can till less, which means you use less tractor, causing less carbon emission, and also important for soil welfare, right? You name it, like insecticides. I know in the city where we live, schools had to be closed because they were spraying aerial insecticide. Once GM cotton was introduced, cut down in pesticide was nearly 80%, right? So that is actually promoting the welfare of the planet rather than, welfare of the planet than the other ways. GMO is not nutritious, which is also not true. GMOs are modified for a very specific thing that you can track and you can actually modify. If you do classical, for example, IR20, when it was introduced, we have no idea what was changed. We selected the desirable trait. But if you applied the same standard that is now being imposed on GMOs, IR20 would not have been released because people will say, so many changes have happened. In other words, classical breeding, the varieties have always not put through the same demand for regulatory purposes like the way GMOs are, which is one of the reasons why I feel that why GMOs were stifled is because of that. But in any case, those are, more importantly, I want to say that GMOs are a misnomer. That means it's a wrong name. Who said that when you put a gene, that is when the first GMO was made? Wrong. Since humans existed, we have always modified plants. I'm showing you an example. Look at the watermelon, wild watermelon, what is today? Wild banana, what is today? Wild carrot, what is today? Or corn, what is today? Teosinte, right? Famous in Mexico, where it originated. Eggplant, what it used to be, now what we did do. To all the brassicales crops, right? We have always modified. Just because it is classical breeding, that is also genetic modification. Nothing, no phenotype will ever change without modifying the underlying DNA. Therefore, this is a bad way people have given the name genetically modified as if before that genes were not modified, which is completely wrong in all possible ways. But the name GMOs have stuck. So I want you to think about it. Every time you hear GMO, is that, well, as long as humans have existed, they have always modified plants, right? There's no doubt about it. Look at this. I've given you a timeline. Starting 10,000 years ago, people were selecting plants. If you go and select, like the way when I was a student in Annam University, we released the famous eggplant, right? It was a natural mutant. That genome was changed. There was no chance without that could have happened. So, but we selected it, right? Then we would cross with other varieties. Again, we are changing the genome. We are always modifying. So it's nothing new as far as I'm concerned, as there's nothing new, right? So I don't have that irrational fear of these plants. We can always test it, but there's really no reason to be afraid of them, is what my point is. Okay, so we have always, like I've given the timeline for 10,000 years ago, we have always modified crops. All the way, GM crops have been introduced. Again, we call this GM, but nobody calls maize a GM. It's a classic example. 16 mutations happened and were selected by Native Americans which led to from teosinte to maize today. So we now know the 16 mutation that happened. You can actually recreate today's maize from teosinte again by selectively introducing those mutations, right? So people just select it. It's just nothing wrong, right? We want higher yield, resistance, and all that stuff. I'm just arguing that it's also genetic modification. Nothing fancy here, right? Like I said, GMO is a misnomer. In fact, regulatory policies, as so bad, so strict for GMOs. In fact, it has drove away farmers who are trying to be helped, right? Small farmers. Only big agriculture companies can compete in this area because only they have the money to go through all the regulatory policies and approve their varieties, right? But again, as I mentioned before, traditional breeding and varieties have not been subjected to this. I asked, why not, right? Why not? If you are changing something, subject them to the same thing. So, in fact, I would argue that don't subject traditional varieties to such stifling regulatory policies. Relax the regulatory policies for GMOs so that we can evaluate them carefully and not take it away from farmers who really need it. This should be part and parcel of sustainable agriculture, right? And also the branding, the naming, and all this fear and this regulation will cause needless confusion, fear among the public, in my opinion. So that's why I call it, let's not throw the baby with the bathwater, right? If the water is hard, we want to throw, but don't throw the baby, right? Then you're losing all the tools. And never give up the tool, because one day we may need it, right? And we are already seeing that we need it, right? I can give you innumerable examples how genetically modified crops were made, but are sitting in shelves of research universities simply because of regulatory policies and fear, right? I have seen a variety developed, a cotton variety. It's the first GMO crop where both yield and quality was improved in single shot, and it was successful in field experiments. But because of fear of GM, they were not developed further, right? So I feel like regulatory burdens stifle it, and I hope policymakers make a change. I'm arguing from the scientist point of view. So far I've told about conventional breeding and genetic modification, and so I'm just making sure I'm on time. And if somebody can warn me or caution me about time, that'll be great. So far I've talked about conventional breeding, where, for example, if you have a sweet and tomato, but it is susceptible to disease, what we would do is we will cross it to a not sweet tolerant to disease tomato, generate the F1, and then we select based on phenotype the desired plant. Then we backcross it to the resistant variety until you get the phenotype tomato, which is sweet and disease resistant. Right? That's why it takes time. Genetic modification, like I mentioned, the GMOs, where you take a foreign DNA, put it in a vector so that it can replicate itself, and introduce it into the plant using all the techniques I described, and generate a transgenic plant so that you can then use it to evaluate for both the tomato has sweet and disease resistance. So in other words, in this case, this pink one is the disease resistant gene that you want to introduce. And because you introduced it into the chromosome, now it is part of the chromosome, it's part of the genome, and it is expressing it, making the tomato resistant and disease tolerant, right? That's GMO. So what is gene editing? So this is something that is very important, and it is here to stay, and it is affecting all aspects of our life. And I hope everybody is up on it, and we have an exciting tool to generate crops, designer crops that will help in the cause, right? So what is gene editing? So in gene editing, let's say for the same challenge of you're having a sweet, good tomato, but it is susceptible to disease. If you want to change it, what we do is we take this technology and delete the gene, for example, that is causing the susceptibility, right? So that's what is shown here. The disease susceptible gene is mapped, and it is targeted specifically, only that gene, and is deleted. And now, once you remove it, you now have a repaired DNA with which you can use it to generate a tomato plant that is both sweet and disease resistant, right? So it's almost like, imagine your computer, you got a delete button. So you can use it to edit a sentence, right? You can delete a sentence, right? In fact, I want to say that people have tried this gene editing trick for a while, right? So in the early, like I mentioned, we only based with mutagenesis. We had no idea which one we are changing. We just use phenotype to guide us. But in the late 1980s and 1990s, using the zinc finger protein or meganucleases, or later on, even 2011, just 10 years ago, TALENs, all these three are protein-based ways to edit the DNA. So it's like, imagine I give you a manuscript with a sentence that has corrections to be made. What you do, you sit down and say, delete that word, change this word, add this word. Now you got a beautiful sentence, right? Like that, using protein that we put into the plant, people were coming up with ways to edit the DNA, correct the mistake, so that the plant can do what you want to do. But there was a problem because it was a little bit expensive, because you have to introduce the protein into the plant, and that was also a little bit time consuming. And also that protein, once it is used, is gone. Now every generation you have to introduce it. So it was a little bit, people were able to edit, but there was some difficulties. Then came in 2012, the biggest revolution, in my opinion, in biology in the last 30 years would be the CRISPR, the discovery of CRISPR, which that is why within 9 years, to 2020, 8 years, last year, Jennifer Doudna got the Nobel Prize for discovering CRISPR, right? So CRISPR was discovered in 2012, where what we were able to do is to correct a change and edit a mistake, right? That's what happened. And now, since then, people have now come up with lots of different versions of CRISPR where you can delete things, you can add things, you can change one nucleotide, just like, if I said weak, W-E-A-K, if I change it to W-E-E-K, you can do it like that, precise. You can change one nucleotide and fix the problem, right? So all of that is now available. People are already using it, and we are now generating crops of all kinds, right? So what is that CRISPR technology is what is shown here. It is actually a protein RNA complex. And we call the protein the Cas9 protein. It has a guide RNA. This forms a complex like shown here. And what it is doing is the guide RNA, as the name suggests, will look for its complementary base pairing in the DNA. If you remember, I told you how DNA, RNA, if it can form a hybrid, that's what is happening. The RNA will match and find its complementary and find exact complementary pairing and do that. Once it does that, this protein is now activated to cut it, which is shown by this thunder sign where it is now. So as a result, what is happening is this DNA is now destroyed, right? You have cut it using a scissor. So you can think of Cas9 as a molecular scissor to cut the DNA into pieces, right? So imagine, so when this was announced, it was a big science paper that said that Jennifer Doudna mentioned that because it is using RNA to guide itself to the precise point, form a base pairing and cut it, I envision that it can be used to cut anything you want. That's how she wrote it. And that's precisely how it turned out, because now we can actually use this technology. If you know the gene that you want to destroy, it's very easy now, because you can use the guide RNA to be like that, send it there. It's like a precision, right? You can now go ahead and cut it. So for example, you can delete it. You destroyed the gene. Now, for example, if you remember that susceptibility gene in tomato, you can delete it. Now you can get it. Insertion, you can insert a new DNA. You can do that. You can also correct small things, like I said. So now gene editing is now possible because of the guide RNA, right? And like I mentioned, CRISPR was awarded the Nobel Prize last year because of that extraordinary capability to edit plants, right? And where did this, in fact, come? That itself is an amazing story, because Jennifer was a microbiologist. She was asking the question, does bacteria have immunity? Does it have immunity against virus, right? So I want to make sure there's no message for me. I just want to make sure. So they had sorry, I lost my thought. Yes, Jennifer was studying bacterial immunity, right? If bacteria is attacked by virus, can it have immunity against it? Until she came around, nobody thought that bacteria has immunity genes against viruses. In fact, it turns out that yes. So here they're showing you like a viral genome when it comes into the bacterial cell is now the bacteria retains small snippets of it shown in color like blue, purple, orange, like that. Small pieces of different viruses are stored in the genome. Why? Next time that same bacterial cell is infected by the virus, now the bacteria has a memory of that virus and it mounts a defense. How does it do it? That CRISPR-Cas9 mechanism, where each of these small DNA pieces are converted into RNA, and it forms a complex with the protein. So you have a Cas9 RNA complex, like they're showing one for blue, one for green, one for purple, one for orange, all armed and ready to go. What they're doing is they're waiting for another invasion by a virus. And if it matches, so let's say a blue virus comes in and it matches the sequence of the RNA, it immediately recognizes, and that protein Cas9 will cut it. Once it cut it, you destroyed the viral genome. Right? This is how she discovered, as a basic research, how bacteria is able to destroy viruses that it doesn't like. Then she said, okay, if I give the guide RNA of my choice, I can send it to a DNA of corresponding DNA and cut it, right? You can do that. And that's exactly what now people are using CRISPR for, is to send it to whatever you want. Now, CRISPR is now being widely used in human health, medicine, you name it. And in plants also, we are now generating disease-resistant banana, decaffeinated coffee beans, flavorful tomatoes, wheat, non-browning mushroom and apples, sustainable rice. So we now can have crops that can be, you tell the challenge, you can specifically design it, right? So imagine like you want this particular shirt, and if this way, you can tailor it, right? Exactly like that. We can now tailor crops to mount challenges, right? In one place there is drought, another place there is flooding. We can now generate plants that can help sustain that challenge because caused by global warming, right? So I also wanted to just walk through quickly with the steps that if you are interested in using CRISPR, these are some of the steps you have to take to generate a variety, for example, and then you can use it. And it is fast. That is the biggest advantage now we have with CRISPR, is very fast. Within 3 to 5 years, we can now generate a variety, unlike before, and it is precision, right? Nobody has any problem with LASIK eye surgery, right? Earlier, we used to kind of think. Now we can precisely destroy certain cells and help with fixing the lens, right? It's like that. Precision is now the theme of the day. These are precision breeding techniques, right? So the first step, if you ever want to use CRISPR for whatever trait you're interested in, you have to identify your phenotype, right? Whatever you're. For example, one can say simple traits like flower or fruit color, bioactive compounds, right? I want a flavored tomato. I want a pepper with a little bit more spice or less spice, whatever you want. Plant and fruit size, for example, maturity and flowering time. Citrus, I know that in a place nearby, they're already growing GM citrus, which can flower in 5 years, and they're able to produce fruits. So farmers don't have to wait for 10 years before fruits are coming up. So you can change the flowering time, maturity time, whatever trait you're interested in. It's like simple traits like that, or complex traits like yield. Yield is always a quantitative trait. Multiple genes are important. Disease tolerant, drought, heat tolerant, which is what my lab is now working on in tomato. Taste or flavor. So whatever trait you are there, you have to identify the phenotype. This is very important. You need to know what genes are associated with it. But don't fear, which is exactly what the traditional classical breeding also, right? I was complaining that classical breeding didn't know what genes they were doing. But here I'm saying I need to know the gene, then how am I going to find it? This is where genomics is now helping CRISPR to become a revolution, is that using genomics, we can now find traits and associate them with genes very quickly, very fast, right? Literally a couple of years you can do it, or even less, depending on the trait. Right. For example, my lab, we are working on thermotolerant tomatoes. So this study was conducted by one of the visiting scientists from Coimbatore, Michu, who conducted this experiment, where we found that there are thermotolerant tomato varieties, and we can actually show that its reproduction is also vulnerable to heat. And we showed that pollen tube growth is affected by heat. Therefore, in the susceptible varieties, when you apply heat, shown here, they grow very less, therefore no fruit. But in the resistant varieties, they grow better, even under heat stress. That means they're making more fruits. That's what he found when he was in my lab. Based on that, we have now developed a genomics and CRISPR-based project where we can now find genes in the tolerant varieties and susceptible varieties, narrow them, and associate the phenotype with those genes in the pistil, the female part, or in the male part, or in the both parts, right? So we can quickly find genes, and then once you find the gene, they are candidates. Now we can generate CRISPR lines of all of them, and if you knock out, are you making thermotolerant variety thermosensitive, right? For example, we can do like that, right? So this is, in other words, my basic point of the step one is you have to identify the phenotype and associate them with the genes. Let's say you're done, right? Now you have to decide, should I do a gene knockout? That means, should I delete the gene, right? Which is exactly what was done with the PPO gene in mushroom and in apple. Now we can, so for example, if you cut the mushroom or apple, this CRISPRed plant and mushroom will not brown anymore. it will remain. So it will be more palatable. So you can cut it and keep it. But this was very level of challenge was very low. Very quickly, people developed these varieties. No big deal. They knew the gene. They know exactly to make the guide RNA, to target it and cut it. It's deleted now. And the cell, one important point I forgot to tell is that, so let's say you cut it, right? In case of virus, when they originally found, no problem, right? You cut the virus, you destroy it. But in case of CRISPR, to be used in gene editing, how did they do it? Let's say it cuts the plant DNA. Don't you think that it will be gone? No. Eukaryotic cells like us and plants have DNA repair mechanisms in them. So they can actually fix the issue for you. And when they fix, they will cause deletion or precisely make some changes and everything. So in other words, you just cut it and let the plant do the job for it. And then you select what you want. Right? So this was a very easy gene knockout people made. It's already available in the market, actually. Then precision editing. Second thing is that there are some cases where you have to decide, should I edit? That you remember I told you that now we have CRISPR-Cas9 that can not only delete, but can change things, right? So for example, herbicide tolerance gene, ALS gene, was modified like this because it was expression level was low. They wanted to increase it. They put a new promoter element was changed. Bingo, they got it. And then now it was producing the tolerance protein in that. Now you can spray it with the herbicide, it was resistant, right? So this was actually successfully done already. So that is precision editing, where the level of challenge is a little bit higher. So you have to select for the correct cells where things have happened the way you want. But once you select, it's easy. Now you generate the transgenic plant and you keep moving. You can also targetedly insert genes. So for example, a drought tolerance gene, Argos 8, was done that way. And that again is challenge is high, right? You have to precisely place the element in that gene locus so that you get what you want. But all of this is now possible, right? A lot of companies are now into the market. They're all doing this. So there's a lot of optimism right now. So what is step 3? Let's say you decided what you want to do. So you know that will tell you what is your editing efficiency. And remember one thing is that even for CRISPR, you need to be able to transform, right? So like the Cas9, the guide RNA, you still need to put it into the plant of your choice. So that is one big challenge that is still remaining, is that not all plants are transformed. You cannot put foreign DNA into every plant. There are many plants you can put, rice. People have developed techniques. But any plant you can transform, you can put the Cas9 RNA combination into it, target your gene and edit it, right? As long as you can put it. If there is a plant that you can't put it, you have to solve the transformation protocol first so that you can actually transform them and CRISPR them and so on, right? Anyway, the transformation frequency can vary between plant to plant. This decides how many product opportunities, and the speed of development is all dependent on these two factors. How fast you can edit, how fast you can transform, how well you can transform, right? So that's how you establish. So you establish transformation and editing protocols. If you have it, now you can generate the plant, right? So literally this is a workflow. So you reagent the designing of the RNA and the protein is just 1 to 2 months, you are done. 3 to 5 months, if you can transform and use the tissue culture, you can get the transgenic plant. After that, it's literally growing the plants and phenotyping them of whether it has the trait you're looking for. Once you edited it, here. So literally within a year, for example, in a good case, or in a little bit tough cases, maybe 2-3 years, you should be able to develop an edited plant. And so then you can just confirm that there are no problems and everything. So, which is what I'm showing here, you have to validate the edited plants, right? So for example, if you have introduced the gene here and the CRISPR-Cas9 RNA is sitting in another chromosome, no problem. It will now work on this gene, edit it. So the green gene is now edited. Okay, great. Now what you do is you backcross to your germplasm, like whatever variety you are targeting. Now, the reason is to remove this Cas9, right? You don't want that molecular sister to always be sitting there. Otherwise, it will keep cutting. So once you cut it, you only needed 1 generation. After that, you should get rid of it. And it's very easy. We can backcross it. And now you can, in the progeny, you can select it. So here again, classical breeding technologies and protocols are helping us, because that's what we are using today to remove this and help with everything. So once you have this plant, so this is your desired plant shown in the left. That's the plant which has the edited gene, but the Cas9 RNA guide is gone. So this plant can now be checked for the phenotype of your choice, whatever trait you're looking for. If it works, you're ready to release it. As simple as that. So where are we now with that is that, so these are protocols are well established. There are now agencies are doing it, companies are doing it, people are rushing in. It's a gold mine right now. And I think that as researchers, I highly encourage to give CRISPR and gene editing technologies and GMOs a chance so that we can also, in India, people can also compete and also help our farmers, right? Many times people are confusing other issues with genome editing and GMOs. So this is one big issue is now that where is the global regulatory side? So in US, many plants are now, if you are genome edited, it is not considered as a GMO crop because you only edit it and there is no transgene sitting there because you remember the Cas9 is removed. Like I mentioned here, this is removed. Therefore, this doesn't have the Cas9, even though you introduced it to edit it. So in US, most of the crops, gene-edited crops are not considered GMOs. So they don't fall under that regulation. So it is now being able to release. But you still have to follow protocols and there are agencies to regulate it. In Canada, I think they are going by product-based regulation. Therefore, I think it is expected to accommodate gene editing. Argentina and Brazil also are going case by case. But European Council, I think you would have read in the news, European Union, in my opinion, are making a mistake. And they have decided to call gene-edited crops as GMOs. And therefore, it will now fall under the same category of regulation and everything, which will stifle development of varieties in Europe. But how will that be in Asia? I don't know. I'm not very familiar with all the policies there. But I hope you and all the researchers will give it a chance and study this carefully, and you shouldn't throw away this huge technology. So in conclusion, what I want to say is that innovation in plant breeding will definitely play a significant role in the future, right? Why are we, I'm actually willing to take questions and answer questions too, but because I've 30 years of experience in molecular biology, I'm telling you, we have sequenced the genome. I know every nucleotide of a tomato plant, right? I know exactly where genes are, where it has been mapped. We now change, when we do GMOs and gene editing, right? Unlike classical breeding, I know what I'm changing. Therefore, I can track it. There will always be off-target effects, like people call it, right? When the Cas9, the fear is that Cas9 will not only delete or edit what you want, it may edit something else. It's called off-target effects. Yes, but with genome sequencing, it is cheap now, right? Within one afternoon, I can now sequence Arabidopsis' complete genome, right? So I can actually sequence all these plants and literally have the bioinformatic tools to quickly say, yep, that's the plant I want because there is no other off-target effect. I can say that, right? And again, nobody's asking that GMOs are immediately planted in the field and given to farmers. Let's check it. Let's put them through the test, right? But I'm just asking that all the varieties be tested that way, or not with such rigor, and allow it to be, freely available to farmers and everybody so they can use it, right? Otherwise, we are going to allow big companies to dominate the field, right? So I think, it should be part of all the varieties generated by it, should be part of, if you want to call it organic farming, it should be part of it, in my opinion. If it is intensive farming, it should be part of it, right? If it is sustainable farming, it should be part of it, because it is a plant that will be able to help meet the needs of ourselves, right? So for example, right, many times people make a mistake of confusing. So let's say I raised a variety like IR20, right? If you drive in Tanjavur district during the 70s and 80s, right, you will see acres and acres of it. That's monocropping, right? So many of the issues that came is because of monocrop, right? If there is a disease, now the whole cropping is susceptible. So at that time, we didn't say that, oh, because we generated this classical variety by irradiating the plant, That's why this happened. No, what we did was we figured out how to manage, how to do pest management, how to do integrated pest management. I still remember Dr. Bhaskaran was my entomology professor who explained that integrated pest management, how to manage it and so on, right? Same way, why can't we deal with it? Because we now have the capacity to track and help and figure out that we should be able to do it. So in other words, people are blaming wrong things on GMOs, is my opinion. I think that first wave of gene editing plants will be in well-characterized genetic pathways. So we know exactly the gene, like the PPO gene I was mentioning. But long-term potential is there. As we understand the complex systems, we can actually generate plants of our needs. Right? I still feel that I'm being very open. I like to challenge conventions, and I don't mind approaching controversial subjects. I can defend myself. I can openly say that EU is definitely treating gene-edited crops like GMOs, and it may put EU under a disadvantage in the future. But how do we, how will it survive in Asia? It depends. We have to see. But with that, I hope I have convinced you that we can modify plants. We have always modified plants. Now we are doing it with more precision, right? People like when military generates a drone that will hit a specific moving target, right? There we are excited about it. That's exactly what we are doing with genome editing. We are being very precise. Therefore, we know what we are doing. Therefore, we can track it. So this allows us to, again, we are not indiscriminately tracking it. There should be a lot of protocols. There should be regulations. I'm not against regulations. I'm just saying that it should not be penalized in such a way that it stifles innovation and growth, right? So I hope with that message, I want to leave with you that GMOs and gene editing crops are important part of sustainable agriculture. In fact, all aspects of agriculture. Which is how we can actually be successful. Because, for example, not all parts of, I know I'm going to say something again controversial, which is coming up with Somasundar, I'm going to talk, organic farming is very important and it should be practiced in all parts of the world. But will it, if the entire world practices organic farming, will it be sufficient yield could be produced to meet all the needs, right? So what I'm suggesting is a hybrid approach where in organic farming, we can have designer crops, be part of them and help with it and achieve that goal, because we still need high yielding varieties that need to perform well in drought and flood and all the other parts. So with that, very controversial thoughts, which I have no problem in saying it. I'll defend myself. I'll be happy to answer questions. With that, before I want to thank my foundation, which started, my seed, right, started in Annamalai University. I'm extremely grateful. The education and the guidance and the interest I developed on plants and of course crops started in Annamalai University, and that continued in TNAU in Madurai campus where I did my master's. Then I did my PhD in Georgia, University of Georgia in USA, where I became familiar with molecular genetics and genetic principles, and in University of Chicago, where I developed the reproduction interest, and now using which I've set up my own lab, where I'm grateful for all the undergraduate students, graduate students, postdoctoral fellows, visiting scientists, collaborators, all of them. I'm grateful because of whom I'm able to talk like today with you all. And I'm very grateful to acknowledge the funding from National Science Foundation in the USA, which has always funded my lab. And I'm extremely grateful because of that, we are able to do the work. Thank you, and thanks for the opportunity. I hope I stayed on time, and I'm happy to take questions.
Thank you very much, sir. Thank you for sharing reality lecture on GM crops and CRISPR and made us not to believe any myths about GM crops and to take step to work on many other crops, sir.
Thank you.
With this, I invite, we heartily welcome Dr. R. Krishnamurthy, sir, as Assistant Professor, Department of Agronomy, Faculty of Agriculture, Annamalai University, to act as moderator.
So thanks for our Professor Dr. P. Ravishankar, who is working in School of Plant Science, University of Arizona, PSA, and he narrate all the things which are very pertaining to this topic, and given why care should be given for the sustainable agriculture, and given about the temperature and its extreme conditions, and also SSB, like synthetic and systematic biology related to genetic engineering, and also the topics or the information related to genetically modified plants such as gene edited of crops, and he given information about the classical plant breeding based on several techniques, and about the world relatives of cultivated crops, and the CRISPR, that is cluster regularly interspaced short plant repeats. So this given a elaborate lecture or information in climatic change, how to overcome the crop productivity in a feasible way. So we thank you one and all, sir. The given information is so useful to our research scholars and also to our crops. So in question chat, well, why all the GM crops are concentrated in yield, and that too mostly in horticulture crops. So why don't you give some more information on field crops? And then another one is, why not the GMO able to develop with respect resistant towards climatic aberrations?
Okay, thank you. Thank you for the kind words, and I'll be happy to answer questions. So I can see in the chat, Satikala Rakesh has asked the two questions, right? Why all GMO are concentrated on yield, that too mostly in around horticulture? No, that is not true. All aspects of all traits of every crop is now being addressed. It's not necessarily horticulture crop. We just happen to work with tomato for a variety of reasons because of genetic and genomic resources. But now that's like you name it, every aspect of it is being addressed. So I can assure you that all traits in all crops are being addressed, and people are working on it, on everything. And also, there's no limit to it, right? For example, if you're interested in some trait, as long as you identify the phenotype and the trait that is important for you, you can go for it. But the only thing is you have to find a way to identify the associated genes. But there are bioinformatic procedures in place and genomic procedures in place. Number two is, why not the GMO able to develop resistance to climatic aberrations? That's exactly what we're working on. So climatic aberrations means that obviously plant can't do much about the climate, but the after effects it can deal with it. Right? For example, it causes drought, causes heat, causes flooding due to heavy rain in certain areas. So people are now developing varieties that are tolerant to heat stress, tolerant to drought stress, tolerant to flooding, and so on. Again, we are finding genes. In my lab, we are working on finding genes in tomato that are important for the tolerant varieties to withstand heat stress and produce a fruit properly, right? So once you know the genes, now we will be able to modify it. So we are actually working on, we cannot, obviously can't, I mean, other aspects of the society has to take care of the climatic problems. But as plant scientists, we can be ready with varieties that will withstand the stress that is being put on us by the climatic aberrations. Yeah, thank you.
Thank you, sir. Thank you. Sir, it is true that transgenic genes in the GMO crop, which will inhibit the growth of succeeding crop, when we are using the same yield of same crops as seed material.
Okay, so that is a good question. So, Jay Surya is asking whether GMO crops will inhibit. It depends on the trait, right? So I think you're asking from the hybrid vigor experiment. So in corn, people plant hybrid seeds, F1 seeds. There, you must plant F1 seeds because you have to cross the two important parents, and the hybrid vigor is only seen in F1. Therefore, you have to plant every time to that. So if the farmer keeps the F2 seeds and plants them, there will be segregation, and only 1/4, if it is a dominant trait, you are going to get only certain portion of the crops, right? So that is why that issue is there. But if we raise CRISPR crops, there is really no reason. Again, GMO crops, not all crops are hybrid vigor seeds, which is also comes under GMO because they are talking about genetically modified. That's not the case. If there is a transgene and if it is homozygous, you can fix it in the population and give it to the plant, right? So here there is a lot of backlash with companies, right? People say like, oh my God, the company is in here to steal my everything and everything. One thing I do want to, again, having seen the patent process and everything in the United States, one thing I want to assure you is that if there is no patent and no protection for the investment, because it is a high risk, a lot of money is being invested, no company will come forward to do it if it is not protected, right? So you have to think from the company's perspective is that everybody's there to make a profit. Nobody's hiding it. But it is important to consider that aspect so that there is reward at the end of that hard work and risk, right? There's no guarantee when the company starts the project, there's no guarantee that the variety will be there, right? So there's usually a thing is that, the companies are bad. We should definitely, work on not to allow them to go greedy and everything. Government can step in. AIDS medicine is a great example where companies develop medicine, but, a lot of nonprofit and governments in the developing countries have worked with them to come up with a plan to distribute the drugs to poor people. Right? Same way, there are ways to do all this. So instead of immediately demonizing companies, make sure that they are also following protocols. Everybody's there to make a profit. Nobody wants to not make a profit. But at the same time, make sure that it is reasonable. Right? If government wants to control that process, well, government has so many research institutes. They can develop the varieties, right? Now CRISPR is available. Everything is available. Now we can actually start making those so that we can give it to the farmers, right? Yeah, thank you.
Thank you, sir. And your own classmate, Dr. Balabhaskar, have asked you to throw some lights on ways for introducing the guide to RNA to plants. So,
yes. Hello, Balabhaskar.
How are you?
I'm doing good. Thank you.
Yeah,
Thanks for the question.
Yeah, actually, I'll just two questions. One is there any specific methodology which will help you to put this guide RNA into plants? Is it a common technique or it differs with plant to plant or trait to trait? That's number one. And number two, what about the stability of these CRISPR plants or the genes that you have prepared? Will the traits be same inherited again and again, or it will not be stable that much? Those two things you can throw some more light.
Okay, good to see you, and thank you for the question. You are looking the same, just like 30 years ago. So, did you CRISPR yourself? Did you genome edit yourself?
Not exactly.
Yeah. So I'll answer the second question first. Once you edit it and remove the Cas9, like I said, then it will be stable. There is nothing there to change it. So once whatever change has been made will remain and stably inherited for generations to come. There's no problem there. So let me share again and show you that I actually kind of mentioned it, but I'll go back to it again. So definitely there are common ways to put the guide RNA and the complex that you want to put into the plant, right? So that's there. Sorry, 1 second. Let me go to that slide and show you that. So if you notice this, I'm going to blow up the slide. So what I was telling you is that for anything you need a guide RNA, right? You can design it like one afternoon. An undergraduate student in my lab will do it like that, right? And then this protein, we know the sequence of this protein, right? So there are vectors that are available. So you introduce it not as an RNA, you introduce as a DNA. So the DNA of this, the gene for this Cas9, the gene that will code the guide RNA, right, are made and are part of a vector. And at that point, you simply transform it into plants, just like you were doing the introducing the foreign gene into this, right? So you will put the guide RNA and the Cas9 in one vector and send it in. That's it. It will go insert itself. This is why we called it like this, to go insert. Sorry. It'll go insert. So the guide RNA and the protein are expressed from a vector. So as a DNA, they introduce it. Let's say it will randomly land in the genome, right? Somewhere it will land. Because all the techniques today, we don't have homologous recombination in plants. Therefore, we don't have control over where it will land. Imagine like a asteroid coming to the Earth, it can hit anywhere, right? Like that, this can land anywhere in the genome. But once it lands, it can produce the protein and the RNA from here, and they will act in trans on the correct. The guide RNA will go and bind because the sequence is here. That's the gene that is complementary to it, and it will edit this one. So it will edit the green gene from sitting here, right? So in other words, you don't have to put the guide RNA as RNA into the plant. You can put it as a DNA, which is easy to transform. It's very difficult to throw RNA into a plant itself. So that's how I would answer this. But once you have this, right, then once you achieved what you want, you can cross it back cross, and in the next progeny, it will segregate. You can discard this plant, and you can keep this plant that has been edited, and that edited version is going to be stable forever. Yeah. So I hope that answered your question. Whatever transformation protocol exists for that plant is what you will use. So rice, you're using callus, for example. For Arabidopsis, we just dip the flower and it'll do a germline transformation. Whatever method you're using, that's what for transformation, that's what you have to use. And that is why I said, if a plant is not transformable using foreign DNA, you cannot CRISPR it. You have to develop that protocol if you need a plant. Yeah.
So the basic designing of your guide RNA itself will be a bigger task.
Yeah, it's actually easy now. It's very simple. Like I said, one afternoon, but you need to know the gene for that, right?
Yeah.
You need to know your target destination. So once you know that gene, you know the sequence. Now you can design the guide RNA. Literally, I'm telling you, I'm not trying to be like one afternoon you can design that. And once you design it, you just make a DNA version of it and throw it into the plant, and it'll take care of it.
Excellent. Okay, just one final question. I don't want to take much of time. Maybe we'll talk later. With regard to disease resistance, do you have any experience on that? And one thing I wanted to clarify get clarified is that pathogens always have this variability. That means they'll change the strain according to situations, environmental changes. In those situations, how this CRISPR plants will react?
Yeah. Okay. So first question is, I don't have much experience with disease resistance, although I'm working in a process that is very similar to fungal or even bacterial interaction with plant cells. But I can tell you that there are very few susceptibility genes, right? That means if you mutate it, the plant will become resistant, because the way immune system works in innate immunity and acquired immunity works in plants is that very few genes are susceptibility genes. That means if you mutate it, if you CRISPR it, you will get a resistance, right? Those are very less, that much I can say. But there are other ways to introduce the resistance through introduction. You can insert a gene and cause resistance. You can do that. Now, the second question you asked is very important, right? CRISPR is not the end of the game, right? Just because it's like an arms race. I develop this defense, I make this weapon. So now I have to adapt to it. It's like the arms race, right? That arms race will never be over. And that is true even for classical breeding. Again, I'm not against classical breeding. So it's almost like I'm always fighting it. No, I'm trying to use it to explain that it is no different than classical breeding. That's what I'm trying to say. Let's say you have a variety resistance. 10 years later, you will develop resistance, right? That's the way, because pathogen is not going to sit quiet and give up. They're going to fight and keep moving, right? So that is why I feel that there is always a chance that you will have to keep changing the plant using CRISPR again to develop additional varieties. Yeah.
Okay, Ravi, thank you. I don't want to take much time, and maybe I've already sent you one message regarding the alma mater development that we are doing in the university. Maybe regarding that, I'll send you communications a little later.
Sure.
Hopefully you'll join, and then we'll keep disturbing you. Okay.
Sure. No problem. Thank you.
Okay, Ravi. Thank you. And thank you, organizers. Krishnamurthy, thank you. You can get along now. Somandaram is already ready, I think.
Yeah.
So once again, I used to thank you, sir, for your detailed information in regard to role of GM crops and CRISPR for our sustainable agriculture. Thank you a lot, sir.
Thank you so much. And I'll answer the chat question on the chat.
Okay.
Thank you very much, sir. Without any further ado, now we are going to move on to the second technical session of today's conference. We cordially welcome Dr. K.P. Sendil Kumar Sir, Assistant Professor, Department of Agronomy, Faculty of Agriculture, Annamala University, to introduce the speaker of this session, Dr. E. Somasundaram Sir, Professor, Tamil Nadu Agriculture University, Department of Agronomy, Coimbatore, to deliver the lecture on organic farming for sustainable food production.
Good morning. It's a great pleasure for me to introduce our next speaker, Dr. E. Somasundaram, Professor of Agronomy, TNU Coimbatore, for this international virtual conference. He is the notable alumni of our faculty, completed his graduation in the Faculty of Agriculture, Annamala University, and did his master degree in TNU Coimbatore by winning ICF fellowship and having won 3 gold medals. He's obtained his doctoral degree from TNU Coimbatore with the area of specialization in organic agriculture and had developed technologies for evaluation of organic foliar nutrition, particularly for Panchakavya, and weed management techniques for multi-varietal seedling techniques, particularly Navadhaniyam in organic farming. The another one, weed management in organic rice production. The next one, quantification of organic sources of nutrients, particularly biogas slurry, manure for maize, sunflower, green gram system. To his credit, he had more than 20 years of teaching experience in undergraduate, postgraduate, and doctoral, and published more than 75 research articles in various national and international journals, and received more than 20 awards for its academic and research excellence. He served as a resource person for more than 250 organic training programs and trained more than 5,000 farmers in India on organic agriculture. I welcome you, sir, for this session. Sir, please.
Good morning to all. Am I audible?
Yes, Soma, you're audible. Yeah, go ahead.
Yeah. Thank you.
Sir.
Sorry, some trouble in displaying my face. Okay, it's also good. So,
Soma, this is Balabhaskar, but your slide share is not there. You can start
slides. I'm not going to. I'm not going to share any slides. I want to talk without any aid. And,
okay.
Yeah, that will be convenient for me because I am talking about the organic agriculture, which doesn't require any aids. I feel so. So I feel happy to see Dr. Ravi Palanivelu after a long time, and since we met at some marriage function. Hello, Ravi. Your presentation recorded. Today, I had some continuous marathon examiner work, so I could not participate fully. So anyhow, at the end, I joined. So good morning, friends and my beloved agronomists. This video link. You want to see my face? One second. Okay, in the meantime, before 1.5 years back, I was heading the Department of Organic Agriculture for more than 5 years as professor and head, and I had the opportunity to interact with core organic agriculturists, I mean the veteran organic farmers, and I had the opportunity since 1989 to travel length and breadth of the state, that is Tamil Nadu, to make a survey of what is going on, what is happening. Okay, so I have visited more than 83 non-governmental organizations. Primarily, they are the people dictating organic agriculture in the state. And I had the opportunity to select some of the sustainable practices, organic farming practices for my PhD work. And one among them is Panchagavya. So I took that foliar nutrition and I just validated, standardized, and I found the scientific rationale behind that Panchagavya. That all, if time permits, I will go in detail. So today, with the experience of 1.5 years of land development and also different development activities, because I have been given 1,100 acres of barren land. Since 1984, it has not been cultivated in Kilikulam. Recently, I have studied Tamil ancient literature called Sripanjamulam. So I'll be convenient here and there to talk something about these type of things. And in Sripanjamulam, they have mentioned, if you do 5 things, then you will go to heaven. You go to heaven. So what all they mean, sir? I will tell in Tamil so that it is easy and convenient for me. Kulam வெட்டுபவன், கிணறு தூர் பார்பவன், தரிசு நிலத்தை விளைநிலமாக மாற்றுபவன், மரம் செடி கொடிகளை உருவாக்குபவன். 5வது வந்து பாத்தீங்கன்னா மழைநீர் வழிந்தோடும் வாய்க்கால், அந்த வழிந்தோடும் இயற்கையாக வழிந்தோடும் வாய்க்கால்களை சீரமைப்பவன். இந்த 5 வேலையை செஞ்சோம்னா சொர்க்கத்துக்கு போலாம் அப்படின்னு. So சொர்க்கம் இருக்கோ இல்லையோ I don't know, but if you do all these 5 activities, then the place where you are living will become a heaven. I feel so. So Sripanjamulam அப்படிதான் சொல்லுது. I had the opportunity to do all these type of works in 1,100 acres where we have raised all type of agroforestry plantation, woodlots, softwood, and rectified 3 big tanks and desilted, and that silts were used, tank silts were used for developing organic fields. And there we raised a variety of crops for seed production, and we regulated the water flow from mountain to storage structures, and we lifted the water from Tamrabarani to 5 kilometers and then distributed the water through subsoil irrigation system. So I had that opportunity, that happiness I want to share with my friends and also agronomists. So now I am confident that if anything is given, then it is possible to develop into an organic farm. That is the thing. And we used to say organic farming, there are so many definitions. I'm not going for a PowerPoint. The reason being, it's not a lecture like, because it's just sharing my experience. So in Tamil, we used to say that பயிருக்கு உணவிடாமல் மண்வாழ் உயிருக்கு உணவிடுதல். That means not targeting the plants. We target, if we do conventional farming, where we have the fixed dose of nitrogen, phosphorus, potash, micronutrients, etc., secondary, everything. But in organic agriculture, we primarily aim for total development of the soil. I mean, that means the land as a whole, like homeopathy, where the whole body is taken care of instead of targeting the ailment or any sickness. So like that in organic agriculture also, பயிருக்கு உணவிடாமல் மண்வாழ் உயிருக்கு, that is for soil life, we focus. I define the organic farming in a very simple one line, that is farming with the safe inputs at optimum level. That's what I used to say. Whatever may be the inputs, அளவுக்கு மீறினால் அமிர்தமும் நஞ்சு. Even in the inorganics, if you even in the organics, if you dump, what happened in the long run, it will become a ecological dumping of bio colonialism will develop. Even if you, sometimes you would have heard about that in the crop cutting experiments. When I was the agriculture officer, I have myself experienced that some farmers in Delta or in other tank fed areas, they harvest more than 15 tons of paddy per acre. They claim that I have applied it 100 packets of azospirillum, 200 packets of rhizobium, like that. That is not required. I feel whatever, even it is a bio input, even it is ecologically safe, அளவோட போடுறதுதான் நல்லது. அதாவது வந்து ஒரு அண்டா பாலா இருந்தாலும், ஒரு சொம்பு பாலா இருந்தாலும் 1 or 2 drops of பிரைமோர், அதாவது வந்து இனாக்குளம் இருந்தா போதும். That everybody we knows. So அதுக்காக வந்து நிறைய போடணுங்கிற அவசியம் இல்லை. அதனால even in organic agriculture also, I used to say that don't dump anything. So அதனால farming with the same safe inputs, because even organic inputs sometimes are unsafe. So they pose problems. They carry the unwanted material from the soil. A very good example I can quote vermicompost. If you use some type of worms, they go up to 20 meter depth, and they will bring out all unwanted things like heavy metals to the surface cultivated area and pose problems. So we need to have a safe inputs, and that also in the optimum level. That's what I want to say about organic agriculture. What in general in organic agriculture, we target 4 things, not to use the 4 things. That is, one is synthetic fertilizers or these pesticides, growth promoting substances, anything, if it growth promoting or growth regulating substances, and feed additives, especially for the animals, we use different feeds, concentrates, and other things. All these four, in addition, the recent times, as the previous speaker well explained, would have well explained all these things. GMOs. I don't think that GMOs may pose problems, but may pose problems in the long run. That's what people feel. That's why it is abruptly, vehemently opposed by the organic growers of India in general. They oppose this. That is tutored by some non-governmental organizations. So it is a blend of tradition, that is ITK, indigenous technical knowledge, that is our forefathers' knowledge, unwritten information, documented here and there. And second one is innovation, that is for involvement, that is you develop something. Every organic farmer is an innovator. They claim that they are the scientists developed this one, that one, Panchagavya, all these are traditional knowledge developed in the long run. And third one is science. We need to integrate science. There, in that spot only, as a scientist, our role is very, very important. Scientific agriculture, I call it as sustainable organic agriculture. Whatever our forefathers practice is organic agriculture, no doubt. Before Green Revolution, everything was organic, used to say. But that time, the type of farming is different. Subsistence farming, only grow and eat it, that's all. The surplus, they will just exchange as a barter system, and they never value. So now the farming is a business. Organic farming is more business oriented one, and wherein we have to calculate everything, and that getting the premium and all these things depends on the quality. So the input usage is a very, very important critical thing in organic agriculture, I feel. Okay, why we need to do the organic agriculture? We know that. I put here and there some of the examples. When you enter into the website and see the Satavik farms, www.satavik.org, you see, starting from the apple to poor man apple, tomato, minimum 3 or 4 third generation pesticides are traveling. It may be pesticide, or maybe insecticide, or fungicide, or anything. So minimum, even the curry leaf in Coimbatore, the curry leaf is known for that Sengambu, Karuvapalai solluvaanga, Karamada areas. It contains more than 4. Now we are trying to convert that area into organic, because curry leaf finds a place in all the stuffs, foodstuffs. So the residue free or contamination free curry leaf is very, very important. So just for example, I am telling. And I had an opportunity to study the biomagnification of the pesticide residues in food chain, because we promote organic agriculture considering and giving weightage to 4 things. That is, one is the major contaminant is pesticide residues. That's why we object to use of pesticides. And second one is heavy metals. The source of heavy metal is fertilizers. Say for example, superphosphate contains 108 ppm of cadmium and 609 ppm of lead. When it enters into the food chain, and if human or animal consumes, then our renal dysfunction will occur. That's why in the recent times, many people are facing problems of kidney failure and all these things, because even if they use optimized dose of fertilizer, even if call it as IPNS or INM, the problem of transformation of these heavy metals, because God doesn't know, or the nature doesn't know that we have the filter to filter all these heavy metals. So our body system struggles as a result. Consequently, the kidney, circulation of these unwanted heavy metals in our bloodstream, resulting in the swelling of legs and also face, everything, and they need to go for dialysis, all these things. That's why we object to fertilizer. Initially, when you see the development of organic agriculture, fertilizers were permitted in some of the countries. In EU standards, they have permitted earlier, and later only they objected the use of it. Everybody criticized. IFOM is the organization globally, it's a non-governmental organization dictating, based in Europe. They are dictating the principles of organic agriculture. They are facilitating through various organic world congress. They are bringing the new latest technologies, so that non-chemical, non-polluting, non-contaminating, safe things they are recommending. So that way, the IFOM is totally objecting the use of any synthetic inputs for that matter. Even if it's a growth promoter, it cannot be permitted. So in organic agriculture, we apply manure. Many times the agronomists claim that application of manure, different type of manure is evaluating in MSc thesis or PhD, and we claim that it is organic agriculture. But many times in organic agriculture, the crops at the later stages of the crop growth, that is after flowering, they suffer. They suffer due to want of foliar fertilization, want of some immunity boosters, want of some growth promoting substances. But that all these things are available in chemical agriculture. So that's why these liquid-based formulations like Panchagavya, this Amrita Karesal, and lot of herbal leaf extracts have come as a remedy, as a foliar nutrition or foliar plant protection stuffs to take care of all these things that we will see in, here and there. So we need a safe food. Enough quantity we have surplus. Even as a buffer stock, we have surplus for another 6 months. But the storage of the buffer stock is an issue, another issue, where we are fumigating, and even organically grown is mixed with the inorganic, because the awareness in organic is now only it has sprung, but it is now only picking up, and premium price, all these concepts in India is yet to develop and get into a full shape. So we have enough quantity, but we need quality. That quality is not assured even now. So we need to have eye on pesticide residues, heavy metals, mycotoxins, nitrates, because they pose problems to human health. So now everybody is health conscious after this pandemic. So everybody is much worried about their immunity level, and also the resistance to these problems. That we may anticipate a lot of things in future also. For that, we have to be prepared. So many of us earning adequately in surplus, but many times the excess or surplus or saving goes to whom? That is for our medical fraternity. So that's why we should be more cautious about the food, because food and our body health is highly correlated. I used to say unavum unarvum onna irukkirathu. That means food and feelings are interrelated. So nilam thiruthi one, that's what our forefather used to say. உணவுங்கிறது என்னன்னு கேட்டீங்கன்னா, food is nothing but நிலத்தோடு நீரே அப்படின்னு அவையார் சொல்லுவாங்க. நிலம் திருத்தி ஒண்ணுன்னு சொல்லுவாங்க. ஏன்னா everybody should till the soil or do something and then get the result out of it, and then we have to. Very good example I could quote is Cuba, where heavily dumped with the pesticides and fertilizers from US and former USSR. Now they are totally dependent on organic input. They generate their own biomass. They are self-dependent.
Somasundram sir, please unmute yourself, sir.
Hello?
Sir,
Okay, sir. You should.
sir, it is audible, sir.
Exercise, am I audible? Sorry.
Yes, sir. Yes, sir.
Yes, okay. So what I want to say is the human and humans are highly related, and in for organic agriculture, the ஆணி வேரே வந்து அங்க வேளாண்மை ஆணி வேரே மக்கு தான் அப்படின்னு சொல்றது. யூஸ்வலா பாத்தீங்கன்னா நம்ம சொல்லுவோம் ஒரு பழமொழி, வாத்தியார் பிள்ளை மக்கு அப்படின்னு சொல்லுவாங்க. அப்படின்னா பை டிஃபால்ட் எல்லாமே அவனுக்கு ஸ்டோர் ஆயிருக்கும். அவன் எல்லாமே அந்த காலத்துல எல்லாம் பாத்தீங்கன்னா வீட்லயே எல்லாம் ஸ்கூல்ல நடத்துவாங்க. அதனால எல்லாமே அவனுக்கு தெரியும். பட் அது வேர் டு யூஸ், வென் டு யூஸ் அது மட்டும் தான் தெரியாது. அதனால வந்து இது ஸ்டோரேஜ், இட்ஸ் ஸ்டோர் ஹவுஸ். ஸோ ஒரு மண்ணு ஒரு சாயிலினுடைய மதிப்பே வந்து அதனுடைய ஆர்கானிக் கார்பன் ஸ்டேட்டஸ் வச்சுதான் நம்ம சொல்றது. ஏன்னா அது ரொம்ப ஸ்டோர் பண்ணவும் முடியாது. ஆர்கானிக் கார்பன் ஸ்டேட்டஸ் 1% நம்ம டிராபிக்கல் கண்டிஷன்ல ஸ்டோர் பண்றது இட்ஸ் எ பிக் சேலஞ்ச், ஹை ஸ்டேட்டஸ்னு சொல்லுவோம். ஸோ 1% நம்ம ஸ்டோர் பண்ணோம்னா there is a possibility of getting 12% more yield. That's what the permanent manual experiments are. These long-term experiments, 140 years experimentation gives an information that organic carbon buildup is very important. That forms the base for organic agriculture. ஸோ நம்ம முன்னோர்கள் நம்ம சொல்லும் போது கூட பாத்தீங்கன்னா கெட்ட இதே சொல்ல மாட்டாங்க. மக்கு பையன் அப்படின்னு சொன்னா நல்ல புத்தி இருக்கிற பையன் தான் அர்த்தம். அதே மாதிரி பாத்தீங்கன்னா மரம் மாதிரி நிக்கிறான், தண்டமா இருக்கிறான், உலக்க அப்படின்னு சொல்லுவாங்க. எல்லாமே பாத்தீங்கன்னா இட் ஹாஸ் இட்ஸ் ஓன் வேல்யூ. இந்த காரைக்குடி இந்த செட்டிநாடு பகுதியிலாம் பாத்தீங்கன்னா அரசாள்பவர் மகனை அப்படின்னு சொல்லுவாங்க. அப்படின்னா திட்டும் போது கூட பாத்தீங்கன்னா அவன் அரசு ஆளக்கூடிய தகுதி உள்ளவன், அவனுடைய ஜெனட்டிக் பேக்கப் வந்து அந்த மாதிரி இருக்குன்னு சொல்லுவாங்க. ஸோ இந்த ஆர்கானிக் அக்ரிகல்ச்சர், the indigenous technical knowledge forms the base technology wise, and in soil, the soil humus form or soil organic carbon or soil organic matter is important. So organic form பண்ணிட்டே இருக்கிறதுல நிறைய அட்வான்டேஜ் every one of us knows. But in the long run என்ன அட்வான்டேஜ் நான் சொல்றதுன்னா eco tourism. That means creating a natural farm, simulating the forest, many forests. There every organism will have its own enjoyment, including the human. So that is ultimatum for developing organic farms. So in the long run ஒரு ஆர்கானிக் ஃபார்ம் டெவலப் பண்ணிட்டீங்கன்னா ஒரு ஆளுக்கு என்ட்ரி ஃபீ மாதிரி போடலாம். 100 rupees per head per day போட்டுட்டு ஒரு சின்ன ஃப்ரூட் ஸ்லைஸ், பப்பாயாவோ ஒரு கோவாவோ ஏதோ ஒரு லோ காஸ்ட் ஃப்ரூட்டா அண்ட் குட் குவாலிட்டி வாட்டரை நீங்க சர்வீஸ் பண்ணிட்டீங்கன்னா that is a service to the humanity. So it's a farming as a business, I told. So integration of science with the yesteryear's science, that is ITK, is the important thing in organic agriculture. Gone are the days people enjoy every moment of nature. Now we separately allocate time and go for tourism or enjoyment in a greenery place and all. So every day we have to enjoy. If you create an organic farm, then by default you will enjoy every day. So soil sustainable organic agriculture is our aim, for which we have to do what are the things we have to do, that we will see. Because I'm going in a very fast mode because already we lost 10 minutes. So I will try to compensate. So plowing the soil with the soil life, that is the first and foremost principle I understood so far. That is Nangul Pulu, that is earthworm, we used to say. 40 numbers per square meter is the ideal population or optimum population in an organic farm. So 40 numbers per square meter means for 10,000 square meter, you know that 40,000 earthworms, and each earthworm every day goes 10 times up and 10 times down. So 20 times they move. And interestingly, every time they will find a new route. So they will not go in the same route as we human practice the safe route and same route, but the earthworms will follow a different route. So 40,000 meters squared, 40,000 numbers into 20 times, that is each earthworm, and 40 numbers per square meter. Totally it comes to 32 lakhs holes per day. Can any machinery, any tool, any implement generate such a porosity? So it's interesting. So we need to create, we need to provide an ambience for the free movement of the earthworms, different layers, we know that. So in the organic horizon, we have the epic layer. So we have to promote the native worms. Lambertus, we know that that is the native worm, Eugenia, all many types are there. I'm not going into detail. So plowing with the soil, like that is the first point. Second, weeds are the children of the soil. That is another concept. So we try to manage the weeds rather totally killing the weeds. So based on weed flora, slight harrowing, because we should not the field. In organic agriculture, we used to say that long run, we have to go to the next step is do nothing, don't do anything, do not go, because the soil life will take care. Do not weed, because we create a eco balance in such a way that weeds will be smothered by another profitable to the human or animal. That kind of plant types will be promoted. So you need not disturb the soil, in the sense I used to say that. அந்த காலத்துல பாத்தீங்கன்னா நாட்டு கலப்பை வச்சு உழும்போது படைக்கால் புழு மறுகால் சேரும் அப்படின்னு சொல்லுவாங்க. நீங்க உழவு ஓட்டிட்டே ஒரு லைன் வரும்போது பாத்தீங்கன்னா இந்த அதிர்வுல பாத்தீங்கன்னா இந்த படைக்கால்ல இருக்கக்கூடிய அந்த பரவல இருக்கக்கூடிய புழுவானது மூவ் ஆகி க்ளவுட் ஏரியாவுக்கு போயிடும். ஸோ எந்த மண்புழுமே கட் ஆகாது. இன்னைக்கு அப்படியா? தட்டுன உடனே பாத்தீங்கன்னா டிராக்டரை போட்டு அடிச்சிங்கன்னா நல்ல பாம்புல இருந்து எல்லாமே அடிச்சு தூள் தூளா போயிடும். எதெல்லாம் சாயில் இன்ஹாபிட்டன்ஸா இருக்கக்கூடிய எல்லாமே பாத்தீங்கன்னா சாயில் லைஃப் சர்ஃபேஸ் விசிபிள் எல்லாமே காலியாயிடு. ஸோ அதனால வந்து we have to take care of all these things. So plugging வந்து ரொம்ப மினிமைஸ் பண்ணிக்கணும், இல்லைன்னா நீட் பேஸ்டா பண்ணு. தட் இஸ் a point I want to convey. So more weeds இருந்ததுன்னா ஹெல்த்தி சாயில் வருவாங்க. ஆர்கானிக் அக்ரிகல்ச்சர் நான் இருக்கும்போது சார் ஒரு வயல் வாங்கலான்னு இருக்கேன், எப்படிப்பட்ட வயலா வாங்கலாம்னா சில கிரைட்டீரியாஸ் எல்லாம் சொல்லுவோம். அப்ப நான் சொல்லுவேன் எங்க கலை வந்து மம்மானியமான்னு சொல்லுவோம், அதாவது ஏராளமா இருக்குதோ அந்த ஃபீல்டு நீங்க வாங்க, பிகாஸ் தே ஆர் த ரிசோர்சஸ். So they can able to pump different nutrients. We used to say தெரியுங்களா 27 nutrients நம்ம சொல்லுவோம் பிளான் growth and development-க்கு. சயின்ஸ் சொல்லுது, அதான் உண்மை. இந்த 27 கிடைக்கிற மாதிரி ஒரு என்விரான்மெண்ட் இருக்கணும்னா அங்க வீட்ஸ் இருக்கணும். ஆனா அதை செக்ல வச்சிருக்கணும், கண்ட்ரோல்ல வச்சுக்கணும். வீட்ஸை ப்ரொஃபியூஸா வர வச்சுட்டு பூக்குறதுக்கு முன்னாடி, ஏன்னா பூக்குறதுக்கு முன்னாடி வீட்ஸ் ஆர் ஹீரோஸ், பூத்ததுக்கு அப்புறம் தான் வில்லன். ஸோ அதனால நம்ம அதை கரெக்டா வந்து வீட் கம்போஸ்டிங் பண்ணி, பிகாஸ் இந்த ரீசன் research, all my MSc students, they tried the wheat compost at the rate of 5 tons per hour. அந்த ஏரியாவில் இருக்கக்கூடிய native weeds, not the exotic weeds. Exotic weeds need to be completely controlled. I agree with that. Example Parthenium and அது மாதிரிலாம் இருக்கலாம். ஸோ பாக்கி எல்லாத்தையும் பார்த்தீங்கன்னா நேச்சுரலி தேர் ஆல் ஹெர்ப்ஸ். ஸோ எங்க வந்து நிறைய நமக்கு வீட்ஸ் வந்து வருதோ அங்க வந்து நம்ம வந்து அதை கேட்டகரைஸ் பண்ணி நமக்கு எஃபெக்டிவா நம்ம யூஸ் பண்ணிக்கணும். ஸோ தட் இஸ் ஒன் அப்ரோச். அண்ட் ஸ்மாதரிங், அதை வந்து வீட்ஸ் பயோமாஸ் வந்து பிஃபோர் ஃப்ளவரிங் அதை அப்படியே போட்டு அமுக்கி நம்ம அப்படியே எருவா மாத்திக்கணும். அது இல்லைன்னா நமக்கு பயன் தரதா. இட்ஸ் ஆல்சோ லைக் ஏ கிரீன் manure. So we have to effectively use it. That is another important point I want to convey. So they are the children of the அதனால அழிக்கணுங்கிறது கூடாது. பயோடைவர்சிட்டில ஆர் டைவர்சிட்டி. ஸோ ஃப்ரம் த பயோடைவர்சிட்டி பாயிண்ட் ஆஃப் வியூ ஆல்சோ we need to check the weeds and make use of it. ஸோ அது இம்பார்ட்டன்ட் பாயிண்ட். அடுத்து மென்யூரிங். மென்யூரிங் பண்ணும்போது பேஸ்ட் ஆன் த சாயில் ஆர்கானிக் மேட்டர் ஆர் சாயில் ஆர்கானிக் கார்பன். நான் முன்னாடியே சொன்னேன் 1% வரைக்கும் நம்ம ஆர்கானிக் கார்பன் கொண்டு போனா அதுல அட்வான்டேஜ் இருக்கு, ஈல்ட் அட்வான்டேஜ். அதனால டிஃபரெண்ட் கலர்டு மென்யூர்ஸ் வந்து நம்ம யூஸ் பண்ணோம். டு ஸ்டார்ட் வித் ஃபாரஸ்ட் சாயில் கிடைச்சதுன்னா அது இன்னாக்குலமா கொண்டு வந்து நம்ம ஒரு நியூ ஃபார்ம்ல போட்டோம்னா is every chance to build up the organic matter very quickly, in turn the organic carbon, because organic matter and carbon are interrelated. 58% recovery organic matter ல இருந்து ஆர்கானிக் கார்பன் எடுக்கிறோம். அதனாலதான் 1.724 மல்டிப்ளை பண்றோம் நம்ம இந்த வால்கிலியன் பிளாக் மெத்தட்ல நம்ம எஸ்டிமேட் பண்ணும்போது. So forest soil is a very good inoculum. It in addition it contains a wonderful material that is mycorrhiza. அதான் வந்து extended root system. Forest soil நம்ம இனாக்குலமா போடும்போது மைக்ரோரைசாவை நம்ம இனாக்குலேட் பண்ணிடுறோம். These are all the simple and easy ways to practice. Soil with organic carbon more than 0.75 இருக்கிற பட்சத்துல நம்ம வந்து இன்க்ரீஸ் பண்ணணும்னா குளத்து கரம்பை ஆறு ஏரி வண்டல் அதை நம்ம வந்து நம்ம போடலாம். அந்த காலத்துல நம்ம முன்னோர்கள் பண்ணதான் டீசில்டிங் பண்ணிட்டு அதை போடுவாங்க. அப்புறம் உங்களுக்கு தெரியும் டிஃபரெண்ட் கலர்ட் மென்யூஸ். ஐ யூஸ் டு ரிப்பீட் திஸ் வேர்ட் பிகாஸ் கிரீன் மென்யூர், கிரீன் லீஃப் மென்யூர், கிராப் ரெசிடியூஸ் அதெல்லாம் எல்லோ கலர் இருக்கும், கிரீன் கலர் இருக்கும். ப்ரௌன் மென்யூர்ஸ் வீடை கம்போஸ் பண்ணி போடலாம். ஏன்னா மைக்ரோநியூட்ரியன்ட் டிஃபிஷியன்சி யூ சி I pose a question to the August gathering. Crops வந்து நிறைய வீடு மைக்ரோநியூட்ரியன்ட் டிஃபிஷியன்சி எல்லாம் காட்டும், ஜிங்க் டெஃபிஷியன்சி, போரான் டெஃபிஷியன்சி அது இதெல்லாம். பட் வீட்ஸ் வந்து செல்டம் ஷோஸ், ரொம்ப 1 or 2 வீட்ஸ் தவிர பாக்கி எல்லாம் காட்டுறது இல்லை. வாட் இட் ஷோஸ், they are having the capacity to exploit or extract the micronutrients from different layers in the soil. It shows that the soil is not deficient, but the way the uptake of micronutrients by the plant roots architecture needs to be addressed. That is the thing I used to say to the biotechnologists. So we have different liquid formulations starting from I rate the biogas slurry is a wonderful material where you can put all the weeds and other biomasses into the biodigester, and then you can use that wet slurry directly into the field. It is wonderful. But thing is 3 years only you have to use because acidity may develop because it contains a lot of humic, fulvic and ulmic acid. So Amrita Karisal is again wonderful. I advocate to the farmers. I recommend the farmers to advocate. That is just simply mixing the cow dung with the cow's urine, and directly for the cattle shed washings, you can ferment for a week time. That is at least 2 days. You can prepare the Jiva Amridam. Jeevangal nirainda amildam. That is the microbes rich one. It contains all the probiotic and effective microorganisms. So that is very effective. So put sugar, that is the jaggery. Jaggery போட்டுட்டீங்கன்னா எங்க இருந்தாலும் பாக்டீரியா நமக்கு நன்மை தரக்கூடிய எல்லாமே வந்திருக்கும். மைக்ரோபயாலஜிஸ்ட்லாம் இருக்காங்க. They will tell in detail. So sheep, goat manure, sheep penning பண்ணீங்கன்னா குயிக்கா ஒரு சாயிலோட ஃபெர்டிலிட்டியை நீங்க என்ஹான்ஸ் பண்ணலாம். கெடை கட்டுறதுன்னு சொல்றது. ஒரு 100 மாடு இல்லைன்னா ஒரு 200-300 ஆடு ஒரு 3 நாள் 5 நாள் வச்சிருந்தா அதனோட வாய்ட்ஸ் எல்லாம் மண்ணுல போட்டு ஒரு உழவு ஓட்டி விட்டுட்டீங்கன்னா ஒரு லைட்டா ஒரு ஹேரோயிங் பண்ணிட்டு அது உள்ள போற மாதிரி பண்ணிட்டீங்கன்னா வாலட்டிலைசேஷன் அந்த லாசஸ் எல்லாம் இல்லாம நம்ம நல்லா பண்ணிட்டோம்னா உடனே ஒரு கிரீன் மேட்டர் வரும். வீட்ஸ் அதுல உள்ள ரிசர்வ் சீட் பேங்க் எல்லாம் முளைக்க ஆரம்பிக்கும். அதையும் ஒரு ஸ்டேல் சீட் டெக்னிக் மாதிரி தண்ணி விட்டு நல்லா வளர வச்சுட்டு பூக்குறதுக்கு முன்னாடி நல்லா மடக்கி விழுந்துட்டோம்னா சாயில போதுமான அளவுக்கு ஆர்கானிக் மேட்டர் கொஞ்சம் ஆட் பண்ணிக்கலாம். இன் அடிஷன் நம்ம ரெக்கமெண்டட் டோஸ் 1.25 kg farm and manure or well decomposed compost வந்து per meter squared. This is the optimum dose 1.25 kg per meter squared. நம்ம அந்த கணக்கு பண்ணி எவ்வளவு ஏரியாவோ அதுக்கு நம்ம போடுறதும் ரொம்ப யூஸ்ஃபுல்லா இருக்கும் from the mineral part. This is the nutrition. Another thing, நமக்கு என்ன இருந்தாலும் அதை எடுத்து கொடுக்கறதுக்கு ஒருத்தர் வேணும் சாயில்ல. That is the we have unpaid servants, that is microbes in the soil. So we can effectively use the decomposer, DNA biomineralizer, quick composting, and that also contains some growth promoting substances and also this biofertilizer value. So அதை நம்ம எஃபெக்டிவா யூஸ் பண்ணிக்கலாம். கம்போஸ்ட் blended with bacterial and fungal cultures are very effective. So biofertilizer, I told about arbuscular mycorrhiza, Bacillus subtilis, Trichoderma viride, Metarrhizum anisoplay, Bioria bassiana, Verticillium lacani, நிறைய இருக்கு, போயிட்டே இருக்கு லிஸ்ட். எல்லாம் என்னோட ஹம்பிள் சப்மிஷன், எதையுமே டம்ப் பண்ணாதீங்க. மேக் இட் as a, I mean, point that it should be used as an inoculum, not as a only see the colony forming unit or the load of microbes in a soil, and then
Kindly unmute yourself, sir. Somsundran, sir. Sir, kindly unmute yourself, sir. Somsundran, sir. Unmute yourself, sir.
I'm audible. Hi, friends. Hi, agronomist. Hi.
Yes, sir. Yes.
Thank you. I'm walking and then talking. So kindly bear with me. So நம்ம யூசுவலா என்ன சொல்லுவோம்னா 21 நியூட்ரியன்ஸ் இன்னைக்கு ரொம்ப இம்பார்ட்டன்ட். 16 சொன்னோம், அப்புறம் ஒரு 5 ஆட் பண்ணோம், இப்போ 21 சொல்றோம். பட் என்னுடைய அண்டர்ஸ்டாண்டிங்ல 27 நியூட்ரியன்ஸ் தேவை. சோ நம்ம பருவங்கள் பாத்தீங்கன்னா 6 பருவங்கள், அதாவது கார், கூதிர், இளவேநீர், முதுவேநீர், முன்பனி, பின்பனி, 6 பருவங்கள் இருக்கு. மனிதனுக்கு அதே மாதிரி மழலை பருவம், விடலை பருவம், குழந்தை பருவம், விடலை பருவம், அப்புறம் பாலிய பருவம், அது மாதிரிலாம் வயோதிக பருவம் எல்லாம் சொல்றோம் இல்லையா, வாலிப பருவம், வயோதிக பருவம். சோ அதே மாதிரி 6 சீசன்ஸ் இருக்கு. இந்த 6 சீசன்ல 2 சீசன் முன்பனி பின்பனியில மழை வராது. அப்படி மழை வந்துச்சுன்னா உடனே வறட்சி வந்துடும். இதான் இண்டிகேஷன். இண்டிஜினஸ் டெக்னிக்கல் நாலேஜ் அப்படிதான் சொல்லுது. பருவம் ஏரி வெற்றி, ஏரிக்குள் எல்லை விதைன்னு சொல்லியிருக்காங்க. சோ அதனால இந்த 4 பருவங்கள்ல பாத்தீங்கன்னா 9 மாசம் மழை பெய்யும். இந்த 9 மாசங்கிறது மாசம் மும்மாரி மழை பெய்ந்ததா அப்படின்னு மன்னர் கேட்பாரு, அமைச்சரை பார்த்து கேட்பாரு இல்லையா, சொல்லுவாங்கல்ல. 3 மழை பாத்தீங்கன்னா வேதம் ஓதும் வேதியருக்கு ஒரு மலை, மாதர் கற்புடை மாந்தருக்கு ஒரு மலை, நீதி நெறிதவரா மன்னருக்கு ஒரு மலை. சோ இந்த மாதிரி 3 கரெக்டா இருந்தாதான், கற்புடை மாந்தர் இருக்கணும், கரெக்டா மந்திரம் சொல்லணும், அதே மாதிரி கரெக்டா அரசாளணும். இதெல்லாம் கரெக்டா இருந்ததுனாதான் இந்த 3 மழை மாதத்துல ஒழுங்கா வரையும். இப்ப ஏன் மழை அதிகமா வரலைங்கிறது காரணம் உங்களுக்கு தெரிஞ்சிருக்குன்னு நினைக்கிறேன். அதனால 9, 3, 27 மழையும் 27 தனிமங்களை இந்த நியூட்ரியன்ஸை பயிர் வளர்ச்சிக்கு கொண்டு வரும். ஏன்னு கேட்டீங்கன்னா உங்களுக்கு 78% தலைச்சத்து காத்துல இருக்கிறத தான் பிடிச்சி யூரியாவா ஹேபர்பாஸ் ப்ராசஸ்ல நமக்கு கோட்டிங் பண்ணி நீமெல்லாம் பண்ணி நமக்கு கொடுக்குறாங்க. ஸோ இயற்கையாவே இருக்கு, அது எடுத்துக்கிற சக்தி பிளான்ட்டுக்கு இருக்கு, வேருக்கு இருக்கு, மைக்ரோ ஆர்கானிசம் அசோசியேஷன் இருக்கு. ஸோ பல வழிகள்ல தண்ணி ஒரு மின்னலானது ஒரு மழை நீரானது நைட்ரஜனை கொண்டு வரும் அப்படிங்கிறதுக்குலாம் நிறைய ரிசர்ச் இருக்கு, எவ்வளவு கான்சன்ட்ரேஷன் கொண்டு வரும் அப்படிங்கிறதுனால. அதனால என்னுடைய இது என்னன்னு கேட்டீங்கன்னா 27 ஸ்டார்ஸ் இந்த கான்ஸ்டலேஷன் அது ஒரு வேதிக் ஃபார்மிங், அது தனியா ஏதாவது வாய்ப்பு கிடைச்சா மறுபடியும் டீட்டெயிலா பேசுவோம். 27 நியூட்ரியன்டையும் அது கொண்டு வந்துடும். ஸோ அந்த நியூட்ரிஷன் பார்ட்டை பொறுத்த வரைக்கும் இதுதான் என்னுடைய இன்ஃபர்மேஷன் என் சைட்ல இருந்து. அடுத்து பாத்தீங்கன்னா காஸ்மிக் அண்ட் லூனார் ஃபோர்ஸஸ் யூஸ் பண்ணி கூட ஃபார்மிங் பண்ணலாம் அப்படிங்கிறது தான் பயோடைனமிக் ஃபார்மிங். அதெல்லாம் இது ஒரு வெர்ஷன்ஸ் ஆஃப் ஆர்கானிக் அக்ரிகல்ச்சர். நிறைய இன்புட்டை டம்ப் பண்ணாம சும்மா ஒரு 50 கிராம் மெனியூர் இருந்தா போதும் என்டையர் 1 ஏக்கரையுமே நம்ம நியூட்ரிஷன் பார்ட்டை நம்ம சாட்டிஸ்ஃபை பண்ணிடலாம் அப்படிலாம் சொல்றாங்க. ஸோ தட் இஸ் அனதர் ஏரியா. ஸோ வீட்ஸை நம்ம யூஸ் பண்ணும்போது மைக்ரோ நியூட்ரியன்ஸ் கிடைச்சிடும். அதே மாதிரி மைக்ரோ ஆர்கானிசம் யூஸ் பண்ணும்போது நமக்கு இந்தியன் சாயில்ஸ் ரிச் இன் பாஸ்பரஸ் அண்ட் மைனிங் ஆஃப் பொட்டாஸ் தான் நடந்துட்டு இருக்குன்னு சொல்றோம். அதனால we need some agents to provide all these things. Secondary nutrients by default incorporation of the biomass calcium magnesium எல்லாம் கிடைச்சிடும். அந்த மைக்ரோ நியூட்ரியன்ஸ் நான் சொன்ன வீடு மேனேஜ் பண்ணனால வீடை கம்போஸ் ஆகி போட்டாவே மைக்ரோ நியூட்ரியன்ஸ் கிடைச்சிடும். ஸோ திஸ் இஸ் நியூட்ரிஷன் பார்ட். அனதர் பாத்தீங்கன்னா நம்ம சொல்லுவோம் மானாவாரி பூராவுமே ஆர்கானிக் தான் அப்படின்னு சொல்லுவாங்க, ஈஸியா பண்ணலாம் அப்படிங்கிறதையும் சொல்லுவோம். ஏன்னா அங்க அதிகமா நம்ம கெமிக்கல்ஸ் யூஸ் பண்ணதில்லை இந்தியன் கண்டிஷன்ல. ஸோ லேபர் இன்டென்சிவ் மானாவாரியில, ஆனா விவசாயமே இன்னைக்கு பண்ண முடியல அப்படின்னு ரொம்ப புலம்புறவங்களுக்கு என்னுடைய சப்மிஷன் அக்ரானமிஸ்ட் அண்ட் ஆல்சோ ஆல் தி பார்ட்டிசிபென்ட்ஸ் நான் சொல்றேன், அந்த காலத்துல விவசாயி எவ்வளவு கஷ்டப்பட்டாங்க அப்படிங்கறது ஹியர் அண்ட் தேர் ஜஸ்ட் சாண்ட்விச்சிங் சம் இன்ஃபர்மேஷன். ஒரு விவசாயி வந்து ஒரு பாடல சொல்றாரு, புறநானூற்று பாடல்ல, ஈன மலை புளிய அகத்தடியால் மெய்நோக அடிமை சாக மா ஈரம் போவதென்று விதை கொண்டு ஓட. ஈனன்னா மாடு கண்ணு போட்டுது, மெய் நோகன்னா உடம்பு அவருக்கு சரியில்லை, அகத்தடியால் மெய் நோக பொண்டாட்டி உடம்பு சரியில்லை, மலை புளிய மலை தூரல் விழுந்துகிட்டே இருக்கு ப்ரீ மான்சூன் சோயிங்க்கு, மா ஈரம்னா நிலத்தோட ஈரம் போகுதுன்னு விதை கொண்டுட்டு ஓடுறாரு அவரு. அப்ப சா ஓலை கொண்டு வருவன் எதிரே வர ஒரு ரிலேட்டிவ் தாய்மாமா இறந்து விட்டான்னு ஒருத்தர் ஒரு நியூஸோட வரான். அந்த காலத்துல மேனுவலா தான் வரும். சர்ப்பம் தீண்ட ஒரு பாம்பு கடிக்குது, அவனை போயிட்டு இருக்கும்போது பண்டில படுத்து ஒரு மீஸ்டா லைட்டா ஒரு கிஸ் பண்ணிடுச்சு. சோ சர்ப்பம் தீண்ட இது வந்து குடிவரியை கேட்டு கோவேந்தன் குறுக்கிட, அதாவது வந்து ராஜா வந்து சேவகர்கள் அனுப்பியிருக்காரு, போன வருஷம் நிலவரி கட்டல இவனை பிடிச்சி விதைக்க விடாம தடுத்துரு அப்படின்னு சொல்லிட்டு. சோ குறுக்களும் தச்சனை கொடு என்றாரு. அப்படின்னா குறுக்கள் என்ன சொல்றாரு, எனக்கு ஆண்டுக்கு நீ கொடுக்கறதெல்லாம் கொடுக்கல, அதை கொடுத்தாதான் உன்னை விதைக்க விடுவேன். இவ்வளவு பிரச்சனைகள், பெரிய லிஸ்டே, நான் டைம்ல அதனால சொல்ல. சோ ஆயின மலைபொழிய அகத்திட்டியால் மெயினாக மாயிரம் போகுதுன்ற விதை கொண்டோட சாவோலை கொண்டு வருவன் எதிரே வர சர்ப்பம் தீண்ட குறுக்களும் தச்சனை கொடு என்றாரேன்னு வரும். சோ இவ்வளவு கஷ்டம் இருக்கும் போது ஒருத்தன் வந்து மா ஈரம் போகுது, நிலத்து ஈரம் போகுது அப்படி சொல்லி அடிச்சு பிடிச்சி மாநகர விவசாயத்துக்கு ஓடுறான்னா, ஒரு விவசாயத்துக்கு ஒரு விவசாயி உழவர் வந்து எவ்வளவு முக்கியத்துவம் கொடுத்திருக்காரு, அதே மாதிரி இப்ப உள்ளவங்க அவ்வளவு கஷ்டப்படுறாங்களா அப்படின்னு திருப்பி கேள்வி கேட்டீங்கன்னு வச்சுங்க, அதுக்கப்புறம் எதுவுமே பேச மாட்டாங்க. சோ அதனால வந்து இன்னொரு இம்பார்ட்டன்ட் திங் ஆர்கானிக் அக்ரிகல்ச்சர் சஸ்டைனபிள் கிராப் ப்ரொடக்ஷன்ல சாயில் வாட்டர் கன்சர்வேஷன். அதாவது விழுக்கிற மழை நீர், ஓடுற மழை நீரை நடக்க வைக்கணும், நடக்கிற மழை நீரை நிக்க வைக்கணும், நிக்கிற மழை நீரை உள்ள போக வைக்கணும். ஒரு துளி கூட மழை நீர் உயிர் நீர் அது வெளியே போயிடக்கூடாது, விண்ணமிழ்தம் சொல்றது. ஸோ அதனால ஆர்கானிக் ஃபார்ம்ஸ்ல அதுக்கு தகுந்த மாதிரி சாயில் அண்ட் வாட்டர் கன்சர்வேஷன் மெஷர்ஸ் நீங்க பண்ணிக்கணும். அப்படி பண்ணீங்கன்னா, ஏன்னா இன்ஸ்டிடியூட் வாட்டர் ஹார்வெஸ்டிங் டெக்னிக் ரெயின் வாட்டர் எல்லாம் ஒண்டர்ஃபுல், அதெல்லாம் வந்து ஃபோலியார் ஸ்ப்ரே பண்ணலாம். நிறைய இடங்கள்ல பஞ்சகாவியா ஸ்ப்ரே பண்றது பேர் ரெயின் வாட்டர் பிடிச்சி வச்சு ஸ்ப்ரே பண்ணு, அது ஒரு இண்டக்ஷன் ஆகி அதுவே வந்து பிளான்ட் இட் செல்ஃப் வில் ப்ரொடியூஸ் லாட் ஆஃப் ஹார்மோன்ஸ் ஃபார் தேர் ஓன் growth. ஸோ அதெல்லாம் நிறைய இருக்கு, சயின்ஸ் இருக்குது. ஸோ அது மாதிரி யூஸ் பண்ணிக்கணும். அடுத்து இம்பார்ட்டன்ட் திங் ஆர்கானிக் அக்ரிகல்ச்சர்ல சேலஞ்சிங், பெஸ்டிசைட்ஸ்க்கு பதிலாக பார்த்து என்ன பண்ணலாம் அப்படின்னு நீங்க கேட்கலாம். இந்த சொர்க்க பனைன்னு அந்த காலத்துல கேள்விப்பட்டிருப்பீங்க. கார்த்திகை மாசம் குளிர் காலத்துல நம்ம கூட ஒரு பான்ஃபயர்னு போடுவோம் பாத்தீங்களா, அதே மாதிரி ஊரெல்லாம் ஒண்ணு சேர்ந்து என்ன பண்ணுவாங்க, எல்லா வேஸ்டையும் தூக்கி போட்டு ஒரு குமியெல்லாம் போட்டு ஒரு பர்னிங் பண்ணுவாங்க.
Sir, please.
சோ அந்த டயத்துல நம்ம என்ன பண்ணணும்னா, இது வந்து ஒரு பெஸ்ட் மானிட்டரிங் ஆர் சர்வேலன்ஸ்னு சொல்லி சொல்றது. அதாவது வந்து என்ன பெஸ்ட் எல்லாம் இந்த போர்த் கமிங் சீசன் வரும் அப்படிங்கறத ஒரு எக்ஸ்பீரியன்ஸ்டு பீப்புள் அந்த ஊர்ல என்ன பண்ணுவாங்க, அந்த சொர்க்க பனையில வாட்ச் பண்ணுவாங்க. என்னென்ன மேல் காம்பனன்ட் வருது, என்னென்ன இதெல்லாம் அடல்ட்டா இருக்குது, இதை வச்சு எப்படி நம்ம பெஸ்ட் மேனேஜ்மெண்ட் பண்ணலாங்கிறது ஒரு இண்டிகேஷன். சோ அதை பேஸ் பண்ணி என்ன பண்ணுவாங்கன்னா, 5 அடுக்கு பாதுகாப்பு. முதல் அடுக்கு உயிர் வேலி, ஒரு வந்து பாத்தீங்கன்னா வேலிக்கு ஒரு மூங்கில், காணிக்கு ஒரு கருவேல்னு சொல்றது. இதெல்லாம் ஒரு வேலியில நம்ம போட்டுட்டோம்னு வச்சுங்களேன், அவ்வளவு தூரத்துக்கு ஒரு கலப்பை செஞ்சுக்கலாம். கருவேல இருந்து கிளைரிசிடியாவை நீங்க பயிர் வெளியா போட்டீங்கன்னா எடுத்து பாடராவும் கொடுத்துக்கலாம், மண்ணுக்குள்ளையும் போட்டுக்கலாம். இது முதல் அடுக்கு. ரெண்டாவது, நல்ல டால் குரோயிங் கம்பு, சோளம் அந்த மாதிரி எல்லாம் போட்டீங்கன்னா பறவைகள் அங்கேருந்து வரும். சோ அடுத்து வந்து என்ன, பெஸ்ட் அண்ட் புஷ் அண்ட் புல் டெக்னாலஜின்னு சொல்றது. பெஸ்டையும் கொண்டு வரணும், அது பிரெடேட்டர் அது மாதிரி ப்ரேயும் கொண்டு வரணும். சோ அந்த மாதிரி ரெண்டாவது பண்ணிக்கலாம். மூணாவது என்னன்னு பாத்தீங்கன்னா, ஒரு ட்ராப் கிராப் சுத்தில இந்த செண்டு மல்லி இல்லைன்னா காட்டு வெண்டை இல்லைன்னா கேஸ்டர் இந்த மாதிரிலாம் ஒரு லைன் போட்டுக்கிட்டீங்கன்னா அது வந்து பெஸ்ட் இழுக்கும். அடுத்து ஃபோர்த் இது என்னன்னு கேட்டீங்கன்னா பண்டு கிராப் சக்கிங் பெஸ்ட்டுக்கு ஈஸியாக நம்ம ஒரு இடத்துல கொண்டு வந்துட்டு அது ஈஸியா கண்ட்ரோல் பண்ணலாம். அஞ்சாவது வந்து ஹெர்பல் லீஃப் எக்ஸ்ட்ராக்ட்னு சொல்லக்கூடிய மெட்டீரியல்ஸ் வந்து இது நாளையும் தாண்டி இந்த 4 வேலையும் தாண்டி ஒரு பெஸ்ட் உள்ள வருதுன்னா இந்த இலைகளை எல்லாம் கசப்பாக்கி விட்டுறணும். அதாவது வந்து ஆடு மாடு திங்காத இலைகள், ஒடித்தால் பால் வர்றது, அப்புறம் வந்து கசப்பு தன்மை உள்ளது, இந்த மாதிரி உள்ளதெல்லாம் நம்ம வந்து கோமியத்தில் ஊற வச்சு ஒரு பெஸ்ட் ரிப்பல்லண்ட் தயார் பண்ணி டெக்னாலஜிஸ் ஆர் தேர். ஸோ நான் ஏற்கனவே நம்மளுடைய வாட்ஸ்அப் குரூப்ல அண்ணாமலை அக்ரி 89ல நான் அனுப்பியிருக்கேன் ஒரு 84 இதுக்கான தயாரிப்பு தொழில்நுட்பங்கள், அதை ரெஃபர் பண்ணுங்க. ஸோ இதை வந்து நம்ம ஸ்ப்ரே பண்ணிட்டா இவ்வளவு கஷ்டப்பட்டு உள்ள வந்து இது கசப்பா போச்சு, இந்த இலையா நம்ம சாப்பிட போறோம், இது ஒரு சேஃப் என்வரான்மெண்ட் இல்லை, இங்க நம்ம அடுத்த ஸ்டேஜஸ் எக் லேயிங்கோ அடுத்து வந்து மற்ற இதெல்லாம் பீப்பேட் ஆகிறதா அட்வான்டேஜ் இல்லைங்கிற மாதிரி ஒரு முடிவு பண்ணிட்டு அதே அப்படி மீறி அதை தங்குச்சுன்னா இந்த மில்லட்ஸ் நம்ம வளர்க்குறோம்ல ஒரு கவர் கிராப் மாதிரி சுத்திலும் ஒரு ட்ராப் கிராப் மாதிரி வருது பார்த்தீங்களா, ஒரு 2 லேயர்ஸ் 3 லேயர்ஸ் போறது, அதுல இருக்கக்கூடிய பேர்ட்ஸ் வந்து ஃபுட்டுக்காக வர்றது, இதையும் வந்து இந்த பெஸ்ட் எல்லாம் கண்ட்ரோல் பண்ணணும். ஸோ இதே மாதிரி நம்ம வந்து ஒரு பெர்மாகல்ச்சர் பெர்மனன்சி இன் அக்ரிகல்ச்சர், அதாவது ஒரு மேன்மேடு ஃபாரஸ்ட் மாதிரி நம்ம அதை கொண்டு வந்துடணும். ஸோ வி நீட் டு ஹாவ் ஆல் தீஸ் திங்ஸ். அடி காட்டிலே நடு மாட்டிலே நுனி வீட்டிலே, அதாவது நிறைய பயோமாஸ் காட்டிலே விட்டுறணும், நடு வந்து மாட்டுக்கு போயிடணும், நுனியை மட்டும்தான் நம்ம என்ஜாய் பண்ணணும். இந்த ஆட்டிடியூட நம்ம இருந்தோம்னா we need to have lead a simple living, be humble and enjoy nature in every breath. ஸோ இதோட நான் வந்து ஒரு சின்ன ஒரு அவுட்லைன் வந்து ஒரு ஆர்கானிக் அக்ரிகல்ச்சர் பத்தி சொல்லியிருக்கேன். ஸோ அதுக்கப்புறம் உங்களுக்கு ஏதாவது தனிப்பட்ட சந்தேகங்கள் இருந்ததுன்னா, நான் ஏதாவது கவர் பண்ணாம விட்டுருந்தேன்னா கூட சொல்லுங்க. இந்த டேட்டாஸ் எல்லாம் நம்ம நெட்லயே எடுத்துக்கலாம். வேர்ல்டுல 187 கண்ட்ரில ஆர்கானிக் அக்ரிகல்ச்சர் பண்றாங்க. 72.3 மில்லியன் ஹெக்டேர் being managed organically by 3.1 million farmers. அதுல பாத்தீங்கன்னா 1.9 மில்லியன்ஸ் நம்ம இந்தியன்ஸ் தான். ஸோ இந்தியன்ஸ் வந்து ஆர்கானிக் அக்ரிகல்ச்சர் பண்றதுக்கு நிறைய ஸ்கோப்ஸ் இருக்கு. ஸோ குளோபல் சேல் ஆஃப் ஆர்கானிக் ஃபுட்டு பாத்தீங்கன்னா போயிட்டே இருக்கு. எங்கேயோ 2019 106 பில்லியன் யூரோஸ் போச்சு. இன்னும் அதை டபுள் ஆகுன்னு எதிர்பார்க்கிறோம். இந்தியாவில் வந்து பாத்தீங்கன்னா கிட்டத்தட்ட 7.8 மில்லியன் ஹெக்டேர் வந்து ஆர்கானிக் அக்ரிகல்ச்சர்ல இருக்குது. அதுல 3.99 கிட்டத்தட்ட 4 மில்லியன் ஹெக்டேர் வைல்டு ஹார்வெஸ்ட் ஃபாரஸ்ட்ல இருக்குது. ஸோ ரிமைனிங் தான் கல்டிவேட். 11,50,000 ஃபார்மர்ஸ் ஆர்கானிக் அக்ரிகல்ச்சர்ல ஆக்டிவ் இருக்காங்க, சர்டிஃபைடு ஃபார்மர்ஸ். ஸோ ஆர்கானிக் ஃபார்மிங் இஸ் நேட்டிவ் டு இந்தியா. வி ஹாவ் inherited knowledge, traditional knowledge to how to do the sustainable. From 1989 onwards, I am involved in organic agriculture research and extension activities. I am observing a lot of things. I interacted with so many farmers, veteran organic farmers. Once they go organic, they will not come back. Even for research purposes, they will not provide land because in treatments we have the inorganic one treatment as inorganic. They will not permit. They will not allow for a and many of the activists are there. They have done a lot of role, like in our Namalvar Ayya, and a lot of people are also. Vanagam is doing wonderful work. But எல்லாத்தையும் ரிசர்ச் பண்ணி அவ்வளவையும் சயின்டிபிக்கா வேலிடேட் பண்ணலாம். எல்லாம் சயின்டிபிக்கலி வேலிடேட்டட். அந்த காலத்துல உள்ள சயின்டிபிக் நாலேஜ் எல்லாம் வேலிடேட் கிடையாது. வாட் இஸ் ரிசர்ச்? சர்ச்சிங் அகைன் ரிசர்ச் தான். அதனால இருக்கிறது தான் நம்ம இது பண்ண போறோம். நல்ல சஸ்டைனபிள் ஆர்கானிக் ப்ராக்டிஸ் எல்லாம் 25 பயிருக்கு நாங்க சிஸ்டம் பேஸ்ல டெவலப் பண்ணியிருக்கோம். நிறைய ப்ராடக்ட்ஸ் 18 ஆர்கானிக் இன்புட்ஸை வேலிடேட் பண்ணி சயின்டிபிக் ரேஷன் எல்லாம் பார்த்துருக்கோம். ஸோ அதனால சக்சஸ்ஃபுல்லா ஆர்கானிக் ஃபார்மிங் பண்ணலாம். நாங்கள் எவ்ரி மந்த் 7th அன்னைக்கு ஒரு ட்ரைனிங் கொடுக்குறோம். ஒன் டே பெய்டு ட்ரைனிங் 590 rupees பர் ஹெட் வாங்கிட்டு நாங்கள் வந்து ஒரு சின்ன மேனுவல் கொடுத்து ட்ரைனிங் கொடுக்குறோம். அதில் நிறைய ஃபார்மர்ஸ் மோர் தென் 2500 ஃபார்மர்ஸ் ஃபேஸ் டு ஃபேஸ் நாங்கள் பேசி நிறைய இன்ஃபர்மேஷன் ஷேர் பண்ணியிருக்கோம். ஷேரிங் ஆஃப் நாலேஜ். ஆர்கானிக் ஃபார்மிங் இஸ் நாலேஜ் பேஸ்ட், நாட் இன்புட் பேஸ்ட். தேங்க்யூ வெரி மச் ஃபார் த ஆப்பர்ச்சுனிட்டி அண்ட் தேங்க்யூ வெரி மச். சாரி, சம் distortions were there, kindly bear with me. நான் வந்து ஒரு க்ரூடு ஆர்கானிக் சயின்டிஸ்ட். ரொம்ப வந்து சயின்டிபிக்கா ஐசிடி எல்லாம் எனக்கு ரொம்ப தெரியாது. அதனால நான் சப்போர்ட்ல தான் பண்ணேன். சம் டிஸ்டர்பன்சஸ் வேர், கைண்ட்லி பேர் வித் மீ. தேங்க்யூ ஃபார் த ஆப்பர்ச்சுனிட்டி. எனி டைப் ஆஃப் இன்டராக்ஷன்ஸ் ஐ எம் ரெடி ஃபார் இட்.
Thank you so much, sir. Thank you for sharing very interesting and insightful lecture on organic farming for sustainable food production, sir. We cordially welcome Dr. C. Ravikumar, sir, Assistant Professor, Department of Agronomy, Annamalai University, Faculty of Agriculture, to act as moderator.
என்னம்மா ஒரு 10 minutes மீட்டிங் முடிச்சிடு. வெயிட் பண்ணு.
Sustainable food production. Sir, you focus each and every corner of the organic farming, especially vermicomposting and its cause and causes of vermicomposting. The lecture very much emphasizes on quantity of organic products inclusions. As in the case of Tamil proverb, allowed to Minjana Amidam Nanji. Sir, because of heavy metals additions to these things. Once again, I thank you very much for spending your valuable time with us, sir. I assure you, you really are you make really a communication. Thank you. Sir, some of the participants write questions. Shall I, sir? Shall I go through the questions? Yes, sir. So one of the question, the participant Vikram. So recently, Sri Lanka faced increase of prices on super oil after following organic food production. What were the reasons behind that?
Echo. Getting echo in this recent crisis. Yeah. So will you allow me to talk about 10 minutes about that? Hello. Hello.
Yes, sir.
Yes, sir. Go ahead, sir.
Yeah. So in Sri Lanka, the situation is totally different. We have to see another angle. It's a financial crisis. The base is financial crisis because the hoarding of food and other materials, they had 2 seasons. So for example, like a Kharif, they have Lua season, and that season they grown fully this inorganic farming only. So there, in that season also, they faced a lot of reduction in yield and faced problems. So in the second season only, they adopted after August 30th only, they strongly recommended to go for organic, banned all the chemical inputs and all these things. So now only they are experiencing. Now many farmers, they are yet to start to take off the second season activities. So before ensuring the availability and otherwise, they have developed a pakka organic farming policy. But for example, in India, and that too in Tamil Nadu, I am very specific. For the past 6 years, we are just fine tuning the organic farming policy. As a member in the organic farming policy committee, I know that every time we are matching with the requirement of the farmer, whether it is possible, whether we can able to generate that huge biomass, because the availability of cattle manure or animal-based manures is a big issue. So there is no good alternative, even though we have developed a lot of technology, farming manure or minimum quantity usage of the mineral component, all these things are concentrated manures or this type of vermicompost and all are costly, transportation, distribution, because they are all bulky in nature. So they have not developed a pakka alternative. They focused only on human health. They are quoting some examples like a kidney failure and increasing number of cancer cases. They have presented in the global forums, and they claimed that this is the first country to become organic with sovereignty and also this safe, that is green Sri Lanka. So no proper planning. Second, they have not generated adequate alternatives. And third one, there is a huge potential for organic agriculture in Sri Lanka. I know that, I have visited also. So a lot of biomass generating activities, and major thing is the plantation crops cannot substitute for food crops. They have wrongly perceived. So the food crops, mainly the rice, globally the rice from Sri Lanka is exported, tea is exported. There is a sudden entry into the organic farming. Because I told in my lecture also that we need to build up the organic carbon status. It is not up to the mark. So they could have entered into the activities, because conversion activities, they have not given much weightage. 3 years. Even for example, Sikkim, the mission started in 2003. In 2016 only, it became a fully organic state. So it took about 13 years. I was also a member in that committee. So we know that it has to be slowly built up. The mindset of the people, the organic carbon status of the soil, and also the that is important for managing all these, especially the pestilent diseases. They are not aware. Even though some of the NGOs are very active in Sri Lanka, they cannot cover all the area unless the government machinery is focusing and giving importance for such activities. It cannot be taken care of in a bigger way. So these are all some of the things. Another thing is hoarding. Food hoarding is a very important thing. That's why they have formulated some one-man committee and then started preventing the speculation and all these things. So the crisis is mainly because they are spending more than $400 million every year for importing the fertilizers. So the financial crisis doesn't permit them to import more fertilizers. That's why they have given weightage for organic agriculture. What they have done is they have developed a pakka organic farming policy, a route map, how to proceed step by step, because people doesn't know how to compost. We have techniques for quick composting, arsening the composting, we're using the biomineralizer, waste decomposer. Lot of things are available in India. Why in many states in India, except 13 states, all states are still reluctant to enter into pure organic farming or full organic farming is because of the non-availability of sustainable organic inputs. We in our department we have validated 18 inputs. We have taken 80 inputs and shortlisted, and 18 inputs only we found sustainable. So many times it invite problems. If you misuse anything, aflatoxin will come. For phytosanitary certificate, you cannot get it for export, or for the human health, it is not advisable. Even though it is from organic farming platform, you cannot take it as a raw, because a lot of things are there. E. coli may come, or the coliform bag, lot of things are there. I'm not going into detail. So Sri Lanka, what even I'm talking with the press persons and NGOs in Sri Lanka, I have suggested some of the things. That's what I want to repeat. So they need to have a pakka organic farming policy. They should have a route map. They should have the organic, they call it as organic fertilizers. Again, it is imported. So the organic farming, it should make them, initially you can get the external inputs. In the long run, it should make the farmer self-reliant. He himself could generate all these things. Biomass generation, all will take time. That's why we used to say for annual crops, 3 to 4 years, or 6 or perennial 7 to 10 years, like that. So a lot of things are there. For want of time, I'm just giving a glimpses.
Thank you, sir. So one more question raised by Sadhana Ravishankar. Is organic agriculture regulated in India? Do the farmers need to use only specific organically approved materials in organic farming?
Yes, you are right, madam. We have national standards for organic production that through 285 pages is available online. So that permitted inputs, restricted use, and banned inputs for organic agriculture. We have guidelines for farming, for animal and livestock management, everything we have. For processing, everything we have the guidelines starting from the year 2001 and validated in 2004. We have NSOP, National Standards for Organic Program Farming, NSOYF, and NSOP is we have NPOP is also the National Program for Organic Production 2004. We have a set of guidelines, and we have for different standards to match with, and regionally also we have Tamil Nadu Organic Certification Department, like that in Karnataka and many places. We government-owned certifying agencies are there under the aegis of APIDA, that is Agriculture Processed Food Export Development Authority. They have set up rules for third-party certification and also for farmers participatory certification. We have guidelines, pakka guidelines, and also organically certified inputs, everything like OMRI in US. We have all the set of things. But according to the state crops and their requirement, we are fine tuning, and then whatever feasible, we are including in the policy.
Thank you, sir. So one more question. Is our organic agriculture really a solution for our climate change?
Certainly, definitely, because it is a climate resilient agriculture, no doubt. Because many times the farmer need not go out of his gate, and it will create a microclimate in such a way that many things, even the pest load, I could observe for the past 7 or 8 years in the Eastern Block farm of Tamil Nadu Agriculture University, where I was the farm manager also for some time. I could see a lot of change in weed shift, a lot of change in pest and disease load, because it has some its own mechanism to adopt and also take care of this microclimate modification, because we always correlate the weather-based pest and disease system, management system, but something unknown things are also exist. But I can't say as a scientist all are unscientific. I can say something cannot be explained. It needs to be experienced, I feel. So definitely this organic agriculture will be a solution for changing climate, especially increased carbon dioxide concentration. Biodiversity will address increase in methane levels and automatically minimal use of the animal millions. Now we have come to a level of 1 ton per hectare or small quantities enriched, or we use liquid formulation like Jivamrita, Gana Jivamrita, only 200 kgs or 20 kgs of cow dung. So we are not the cause for, because many times we claimed that the use of animal manures, we are the troubleshooters in global heating or this methane emission. All these can be addressed. In organic farming, the weeds play a significant role in altering the microclimate climate in any system. So, and we develop a lot of Uyirvelis, that is live fencing, and also intercrops. We go for multiple crops, bun crops. I told you a lot of things, creating the biomass through the growing of trees, shrubs, pest repellent cafeteria. We have very good pest repellent cafeteria. Another important thing, this integrated organic farming system, that is very, very important. Now developed. TNA has validated integrated organic farming system, where one complete recycling, only the harvested nutrients will be given back. That too, in the long run, no need to give back, because of the increased biomass accumulation and generation, it will cater the nutrient requirement of the crop, and that too in the critical stages of the nutrient requirement. Many times what we apply as a manure may not match with the critical stages of nutrient requirement. That will be well addressed through the integrated use of bio, organic, that too in solid and liquid formulation. Just Jivamritam 2000 liters percent, that is the ratio. That is enough for many of the vegetables. So just applying 1 ton of poultry manure and then foliar spray of Panchagavya. Panchagavya is a wonderful thing. Theninum அதாவது வந்து என்ன சொல்றது, I can talk more on Panchagavya, but want of time. It contains a lot of nitrifiers, ammonifiers, chemolitho autotrophs. There is a set of colonies. When we spray pillow and microflora, it promotes, it augments the nitrogen availability in the leaf surface. Ultimately, more photosynthesis, more source to sink. So, 78% nitrogen இருக்குது. ஈஸியா கிராஸ் பண்ணணும்னா foliar spray of Panchagavya பண்ணா போதும். It contains lot of fatty acids, alkanes, alkenes, alcohols, every lot of things are there. So அதனால பாத்தீங்கன்னா 18 nutrients வந்து பீக் நாங்க ஐடென்டிஃபை பண்ண PhD ப்ரோக்ராம்ல. சோ அதனால வந்து TNA Panchagavya சேல் பண்ணிட்டு இருக்காது. This is a very sustainable input. Vermicompost plus Panchagavya is a wonderful combination package for many of the crops. Hope I have addressed some of the things.
Thank you, sir. Sir, on behalf of the organizing team, once again, thank you very much for your spending of your valuable time with us, sir. I assure you, you really make it as an informative session, sir. Thank you.
Thank you. Thank you for the opportunity, and to my good friends, Mayappan and Sivakumar, for whom I always oblige. And that's why midst of the exams, agreed and participated. So thank you for all the listeners. If anything goes wrong, kindly inform me. And I am in the learning process. Organic agriculture is a big ocean. So I have just enjoyed half of the drop. I can't say full drop. So it is everyday learning. So we need to promote, because we are the identity for organic agriculture, and globally we can dictate the entire world. If we practice our traditional, keep our traditional knowledge, information is a treasure trove. So we have to keep it up. And as I appeal to the agronomists, so don't think that organic farming is not feasible. You cannot meet out the food requirement. There are a lot of questions I anticipated. எல்லாருக்கும் சாப்பாடு கிடைக்காது அப்படின்னா 3 வேளை திங்கிறவன் ரோகினா நோயாளி, 2 வேளை திங்கிறவன் போகி. எவனால அஃபோர்டபிலிட்டி இருக்கோ அவன் தான் 2 வேளை சாப்பிடுவான். 1 வேளை சாப்பிடுறவன் யோகியா வரணும்னு நினைச்சீங்கன்னா, நான் இப்போ 2 வேளைக்கு குறைய பார்த்துட்டேன். 1 வேளை ஆகிறதுக்கு கொஞ்சம் கஷ்டமா தான் இருக்குது, பிகாஸ் ஆஃப் பாடி ப்ராப்ளம்ஸ். ஸோ அந்த மாதிரி நம்ம வந்துட்டோம்னா ஃபுட் ப்ரொடக்ஷன் எங்கேயோ போயிடும். நீங்க மென்னு குறைச்சி ஒரு கை கவலத்தை வந்து 15 நிமிஷம் மென்னு சாப்பிட்டீங்கன்னா பசி அடங்கிடும். ஏன்னா அந்த மாதிரிதான் நம்மளுடைய சிஸ்டம். சும்மா உள்ளது எல்லாத்தையும் பல்கி ஆர்கானிக் மாதிரி நம்ம உள்ள புஷ் பண்ணிட்டே இருந்தோம்னு வச்சுங்க, எவ்வளவு இருந்தாலும் பத்தாது. ஸோ அதனால ஃப்ரீக்வன்சியை குறைக்கணும், ஹெல்த்தி ஃபுட்டா சாப்பிடணும், நிறைய பிசிக்கல் ஆக்டிவிட்டி நம்ம பண்ணும்போது நல்ல மனநிறைவோட ஹாப்பியா இருக்கணும். நல்லதே எண்ணுவோம், நல்லதே செய்வோம், நலமுடன் வாழ்வோம். நன்றி, வணக்கம்.
Thank you very much, sir. Thank you very much, sir. There were two sessions which were thought-provoking sections, and we are very fortunate to have both the lectures today in this conference, sir. With great pleasure, we welcome Dr. G. Shivkumar, sir, Assistant Professor, Organizing Secretary of the Conference, Department of Agronomy, Faculty of Agriculture, Annamalai University, to present report of the conference.
Good afternoon, participants. International Virtual Conference on Redesigning Sustainable Food Production in the Context of Climate Change, organized by the Department of Agronomy, Faculty of Agriculture, Annamalai University, was started with a traditional Tamil Thai Valthu. The international conference was kick-started with an inaugural address by the respected Dean, Faculty of Agriculture, Dr. K.R. Sundaravaradarajan, and the felicitation was given by the respected Head of the Department of Agronomy, Dr. V. Imayavaramban. The first keynote address was addressed by one of the greatest alumni of our historic Faculty of Agriculture has ever produced, and my classmate of 1985-89 batch, Dr. P. Ravishankar, Associate Professor, School of Plant Sciences, University of Arizona, USA, who had given a spectacular speech on the role of GM crops and CRISPR for sustainable agriculture, which was moderated by Dr. R. Krishnamurthy, Assistant Professor of Agronomy. The second keynote address was also addressed by another jewel in the crown of Faculty of Agriculture, alumni of 1985-89 batch, and also my classmate, Dr. E. Somasundaram, a renowned organic specialist, Professor of Agronomy, TNAU Coimbatore, who gave a scintillating eloquence on organic farming for sustainable food production, which was moderated by Dr. C. Ravi Kumar, Assistant Professor of Agronomy. A total of around 400 members participated in the conference, and the vote of thanks to be delivered by Dr. R. Rex Immanuel, the co-organizing secretary of this conference. Thank you.
Thank you, sir. I take this opportunity to extend a hearty welcome to Dr. R. Rex Immanuel, sir, Associate Professor, Co-Organizing Secretary, Department of Agronomy, Faculty of Agriculture, Annamalai University, to deliver the vote of thanks.
Good afternoon to all. It's a time to express our vote of thanks. Okay, first of all, on behalf of this international virtual conference organizing committee, I would like to express our gratitude to the authorities of Annamalai University for giving permission to conduct the international virtual conference. Then we wish to express our heartfelt thanks to our beloved Dean, Professor Dr. K.R. Sundaravaradarajan, sir, Dean, Faculty of Agriculture, for gracing this conference. We are extremely grateful to our former Dean, Professor Dr. M. Ganapathy, sir, for showing his interest for organizing this conference, then continued support and able guidance. Then we wish to express our deep sense of gratitude to our beloved Head of Department, Professor Dr. V. Imayavaramban, for his constant and invaluable guidance. We would like to sincerely record our thanks to today's distinguished speakers, Dr. P. Ravishankar, Associate Professor, School of Plant Sciences, University of Arizona, USA, and Dr. E. Somasundaram, Professor of Agronomy, TNAU, Coimbatore, for their thought-provoking and lucid lecture on role of GM crops and CRISPR for sustainable agriculture and organic farming for sustainable food production. Thank you, sir. We wish to thank Dr. M. Prakash, Professor of Genetics and Plant Breeding, for their guidance and support. Thank you, sir. Our profound thanks to various committee members, teaching fraternities of various departments, non-teaching staffs, PhD scholars, especially S. Ragesh, T. Divyasri, V. Vikram Sai, Naveen Prasad, and Ashok Chakravarti, and PG students for their selfless, sincere services, which paved way for the successful completion of this conference. Above all, we wish to thank the participants from various parts of our nation and world who have showed interest to register and participate and make this international virtual conference an unique one. Any omissions there, in spite of every effort to acknowledge the helps rendered is inadvertent. Thank you, one and all. Thank you.
Thank you all. We are at the end of the session. Let us end this program with national anthem.
हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
అబ్బాయిను ఈ పాడి అయిపోయి
తీసుకున్నావా? ఓకే 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 అదేరా పోవట్లేదు నెట్ స్లో.
బాక్సెస్ అన్ని బాక్సెస్
వాడు సెండ్ చేయ తేజకి ఇంక మళ్ళీ సెండ్ చేస్తాను పోవట్లేదు.
ఇది ఉందిగా
అది
అది నమ్మదు
ఇది ఏదో మళ్ళీ కాదు బయట
ఇది ఎట్లా ఉంచారా? ఇది కేబుల్తో ఉంటే
నాకి చెప్తా
సేవ్ చేసే కదా
సార్ ఐ విల్ యూస్ ఫోన్ చార్జింగ్ అవతలకి వచ్చాను.